Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the General Physics 1 helping session provided by the Jubail University College. I'm your host, Abdullah Saad. As mentioned in the WhatsApp group messages, the helping session will have a quick look at the notes and the main concept of the lecture itself. And then if anyone has anything, you can stop me at any time. You can type your question in the chat, it's okay. Later on, we will solve the recommended problems, and I will go over them until everyone can understand them. So please, if you have anything, stop me at any time, and be sure that you understand the point before we move on. If you want me to switch to Arabic, just tell me. But the university regulation is to keep it in English as much as possible. Today, hopefully, we'll be covering the three first chapters so that we're finishing from the quiz material, and we'll see what will happen. I'll start by saying that those slides are provided by Dr. Arun Kumar from our university. I've used them the past semesters, and they were good, and many people really encouraged me to continue on doing so. So I will be using them once again. But just to be clear, those slides are not mine. They are for Dr. Arun Kumar. Okay, so the first chapter is basically talked measurements. It's a basic chapter with the basic concepts. So if you can just focus for a minute, we will be done with it probably faster than the other chapters. So you have to know what do you mean by the base and the derived quantities, physical quantities and their units. You have to know what is the SI units. You should know the basic units of length, time, and mass, and how do you change units using the conversion factors. So we will go over those. Basically, it's talking about if you're making a measurement and what are you doing in your life. So your weight, when you read time on your watch, when you take the temperature, this is all the ways of measuring. So we have a standard, and we should follow the standard as engineers. And so here it says we measure each quantity by its own unit or comparison with a standard. Okay, so it says here, this is the definition of a unit. A unit is a measurement of a quantity that scientists around the world can refer to. So whenever someone says meter, 1 meter, it is approved all around the globe that that meter is defined and is not changing. And here this line, it says this has to be both accessible and invariable. And the meaning for this is, in this example, it says 1 meter is a unit of length. Any other length can be expressed in terms of 1 meter. And then a variable length, such as the length of a person's nose, is not appropriate. So our units has to be invariable, not changeable. It should be something that is always constant. So here in the example, he said you cannot take a nose as a unit of measurement because everyone has a different nose. And so this is the main idea over here, is that the meter is always meter anywhere you go. And this is the basic definition of a unit. Moving on, here we will be talking about the SI system itself. So it's the International System of Units. It has its definition. It has some physical quantities, so quantities which can be measured using equipment and reported in numbers and units. Okay, and we have two types of physical quantities. You have the fundamental and the derived ones. Okay, so the fundamental quantities and base units, and you have some derived quantities that came from the fundamental ones. Here we have a table that shows the fundamental quantities. So we know that length is in meter and the symbol is m. We know time is in seconds and the symbol is s. We know mass should be in kilogram and its symbol is kg. And we have 4 other fundamental quantities that normally not played, but you will get recognized with them. So the first of them is the electrical current, ampere. Its unit symbol is A. You have the temperature in Kelvin, it's K. The amount of substance, you will find this in chemistry. The unit name is mole, and this is its symbol. And we have luminous intensity, which is basically in Arabic شدة الإضاءة. So the unit name would be candela, and the unit symbol is CD. So we will be playing around with most of those in physics. You will find the others in physics too, but right now we'll be focusing on the first three. We have also some derived quantities. When we say derived, it means that it came from a fundamental or an original quantity. So for example, if we're talking about area, it's basically length times length. If we're talking about volume, it is length times length times length. So it's cubed. If we're talking about velocity, it's distance by time. Distance is basically length, so it's meter by second. So you get the idea here is that we can derive quantities based on the fundamental units that we already have, which are the meter, the second, the kilogram. Here you have the force, which is mass times acceleration. You will find that later on we have a law is called Newton law. F equal ma. So the mass would be in kilograms, and acceleration would be a, which is meter per second squared. So the Newton is a derived quantity which came from all those basic units. Moving on, now we have some prefixes. Whenever you have a large number, you can denote that number with a scientific notation. And this scientific notation is basically the power of 10. So here we have a very good example. You have this huge number, and then you can write this number in scientific notation like this. So basically you're moving the dot. So let me write it down over here to make things easier. We have 6 zeros. So this number has a dot at the far right corner. But this dot is not shown because we don't have any decimal places. So whenever you want to change this to a scientific notation, you have to move this dot to the left. Okay, so we move it like this. We start moving in between the numbers, and the amount of movement will be the زي ما نقول الأس حق العشرة. So we will move it here 1, 2, 3, 4, 5, 6, 7, 8, 9. We will move it nine places. So this dot, when it's moved, it will be 3.56. And because we moved 9 digits, you will say it's the 10 to the power of 9. So this is basically the scientific notation. Here it says, sometimes there are special names used for describe very large or very small quantities. So if you can look at this table, I'm sure you know some of those names. You have seen the milli. So whenever sometimes you would hear the word milli or centi or micro or nano. Yes, sure. So sometimes you would say giga, mega. You can see those when we're talking about storage. So gigabyte, megabyte, kilobyte, millimeter, centimeter. So those prefixes are basically the scientific notation for those things. Now you don't have to memorize all of them because with practice you will memorize most of them, but you should know the basics. So let me just do this. So you should know the basics over here. You should know giga, mega, and kilo, and you should know the centi, milli, micro, nano, and pico. Those are the most common used ones. So just try to memorize them. They are easy. You could say 12, 9, 6, 3, and you could go down and then remember those names. Because you could get, so for this example, you could see here, it says 2.35 times 10 to the minus 9 seconds. So you should know that minus 9 is nanoseconds. It comes in the quizzes a lot where it says just convert from the scientific notation to words. So it wouldn't be good if you didn't memorize this, or at least get yourself familiar with. Leave those the ones that are not in dark black, because they are not typically used. But the ones in bold, they are really, you can see them everywhere, especially in physics and this course. Moving on, here we will see some history and definitions for the length and time and the mass itself. So really, it's just a matter of reading, but you can see that the length, it has been redefined many times, but the most recent one is this. So it says, the meter was defined as the length of the path traveled by light in a vacuum. So you have a vacuum and you have light, and the light is traveling inside that vacuum within this time period. So 1 over this huge number of a second. And then they will measure up, and then they will find the meter itself. Honestly, I've never seen any history related questions, whether in quizzes or midterms. I don't remember about the final, but I don't remember any history or definitions like that. But it's really recommended that you know the basic idea of it. Again, here it's showing you a table with some examples of length. So this is for your own information. By the way, if you need any, if a question pops up and he tells you that we need to use one of those numbers, he will give it to you. You don't have to memorize those. Again, here you have the time. It gives you some definitions of time. Basically, the latest definition is that the second is defined as the duration of this amount of oscillations of light emitted by this atom. So again, it's all scientific definitions that are based on experiments and stuff like that. So you should know a basic idea. Yani. It could come. I'm telling you from now. I've never seen it in a quiz or a final, but if it comes, you should know at least it is a amount of oscillation, some amount of oscillation emitted by an atom. You don't have to memorize the exact numbers. Okay, moving on. There is also some common time intervals. So it's giving you the length of day in seconds. So I don't know if you want to memorize that, but for sure you don't need to. Again, this is only for your information. Coming to the mass, this was a huge debate a few years ago, where the kilogram itself was defined by the mass of a platinum iridium cylinder, 3.9 centimeter in diameter and in height. So if you can look at this picture over here, you have this huge glass thing, and then there is another glass thing inside it, and then here you can see the mass itself. They are keeping it in between two different vacuums so that air cannot take away from the particle itself. So the mass itself would be preserved in that place. And this has been in France and many other countries where the kilogram is defined by only that mass itself. But then this definition has changed, and I don't have it in the notes right now, but the definition has changed, and it is, I believe it's based on the carbon-12 atom right now. So they changed the definition, and scientists have agreed upon another thing. So yeah, it says another unit of mass is used for atomic mass measurements. The carbon-12 atom has a mass of 12 atomic mass units, defined as this number. So yeah, they redefined the kilogram and they skipped using the actual mass. Again, here, this is for your information, some masses. We have our galaxy is this amount of mass in kilograms. So yeah. Okay, now we come to a derived quantity, the first derived quantity, which is the density. Please don't mind this. I think this is a mistake. We have here, it says density is typically measured in kilogram per meter cube and is often expressed as the Greek letter rho. This is again wrong. So this is the Greek letter rho. It denotes density, and this mass, and this is volume. And as it says over here, it's kilogram per meter cube. So we will have some question based on this, where you would find the density, or you would be given two of the quantities and you are asked to find the third one. Okay, we come to another topic here in our subject, which is changing units. Changing units is really simple. You do it all the time, but when it comes to physics, you have to do it in a systematic matter. So let's read along. It says, based of the base units, we may need to change the units of a given quantity using the chain link conversion. So we are using a method called the chain link, where you would have the, let's say, the quantity that is given in the question over here, and then you would multiply it with certain factors in order to find your final answer. Okay, so let me just read over here. For example, since there are 60 seconds in 1 minute, so you would say that 1 minute is equal to 60 seconds. And you can write it like this. You can write 1 over 60. And you can write 60 over 1. And we call this a conversion factor. So whenever you see some odd numbers like this, they usually mean a conversion factor, because 1 minute over 60 seconds is equal to 60 seconds over 1 minute. It's just a multiplication. And so whenever you see this, you should memorize it, and you should know that it's called a conversion factor. So it says here, conversion between one system of units and another can therefore be easily figured out as shown. So here is the example. It says 2 minutes. He wants to change it to seconds. So he will be multiplying 2 minutes by 1, and then he's using the 1 as a conversion factor. So he used the 60 seconds by 1 minute. And then since the minute is in the denominator, so this will go with this. And then you'll multiply 2 by 60, and you will get your 120 seconds. Moving on, we have different conversion factors. So here, it's given us an example. He says a boy is 17 years old. Calculate his age in those different things. Okay, so one by one. Let's say he says in days. So if we look over here, he has given us the conversion factor. Sometimes, not sometimes, the conversion factor should always be given unless it's very obvious. Yani you might find a question where you have to change from, let's say, an hour to second. He won't give you the conversion factor between hour and minute, and then minute to second. You should know this. It is very basic, unless it's something not basic or something not commonly used in questions. The doctor will give it to you. But from now, normally in quizzes and exams, everything is given. Okay, back to our question. The boy is 17 years old, and we're trying to find his age in days. So we look at the conversion factor. Here we see. Let's look at the solution right away. It says in days, so 17 years by 1. Here we're using the first conversion factor, that 1 year is equal to 365 days. So this, you should know it. Yeah, it's one of the common ones, but sometimes it's given in the quiz. So it's up to you. So here he just used the conversion factor. By the way, the conversion factor, when we say 365 by 1 year, you all know that is the same as saying 1 year by 365. We just saw it in the previous slide. So you play with the conversion factor as much as you want. So since he gave us in the question years up above here in the denominator, we should keep the year in the denominator so that it goes with this one. And then you just multiply 17 by 365, and you get your full days. The second one, it says in hours, and so since the other conversion factor says 1 day equal to 24 hours, we already have the days, so he just used it over here. See, 6205 days by 1, and then he used the conversion factor, which is hours to days. Again, the day is in the denominator so that it will cancel out like this, and then he just multiplies. Okay, same thing goes for minutes. We already have the answer in hours. Again, you will use the conversion factor for hour and minute, so 1 hour is 60 minutes. He multiplied the same way. Hours is in the denominator, so you can skip those like this, and then multiply, and you'll get your age in minutes. And again, in seconds, just doing the same method. So this is called the chain link, by using the conversion factors. You might find a question where it says the boy is 17 years old, and then calculate in seconds. So you have to go through all this one by one, or you can type it just in one line where you start with this and then you go on one by one. You use this factor and then you use this factor, use this one and then use that one, so that everything can be skipped with each other. Okay, مفهوم هذا الشيء؟ مفهوم الconversion factor؟ Okay. Okay, moving on. We have another conversion factor here, which is one of the most common ones. It says there are 2.54 centimeters in 1 inch, and then the question is how many inches are in 17.3 centimeters. Okay, so you just use the conversion factor since he's giving you in centimeter. So he typed it in 17.3 centimeter over 1, and then using the conversion factor 1 inch by 2.54, you will get your answer. So just pay attention to the conversion factor and whatever the unit he wants. So here he's asking how many inches. He wants the inches. So inches should not be cancelled. You should cancel the other unit. And so we have the centimeter is in the denominator so that it can be cancelled out like this. And then you do your calculation and you will find the answer. Here is the thing that I just talked about, combination or using the chain link. So the question is saying convert 0.083 kilometer per hour into meter per second. So you have to do two different things at once. And so he will give you the conversion factors required. 1 kilometer is 1,000 meter, 1 hour is 60 seconds, and 1 minute is 60. 1 hour is 60 minutes, and 1 minute is 60 seconds. So you can take it one by one. This is the basic idea, which is 0.083 kilometers per hour, and then he's changing. So he's typing your kilometer, 1,000 meter per 1 kilometer. Okay. So this will go with this, and then he changes to 83 meter per 1 hour. And then he came back again and changed the hour in 2 seconds. So since the hour is in the denominator, he used this first factor. So this will go with this, and then you are left with minute. So you can use the other factor, and this will go with this. So just pay attention to where is the position of the unit that you want to cancel out, and you should have the other unit up above it. Okay, let me just go over this again. I think I didn't do a good job over here. So we have 83 meters per 1 hour. Since this hour is in the denominator, we need something up above to cancel it. So he put 1 hour over 60 minutes like this. Again, we said that it's the same. If we said 1 hour over 60 or 60 over 1, it's the same as long as we're talking about conversion factors. So yeah, he used it over here. You will skip hour with hour. Now your minute is in the denominator. You will use the other conversion factor, which have the minute up above, and then you will do the same thing, skip it together, and now خلاص, you're done. You have your meter over here and you have your second over here. Just do the calculation and then you will find your final answer. Are we good on the combination of units? Yes. Yes, Mr. Muhammad. He says, is it okay to do it like this, 0.083 times 3.6? Of course, you can use a bigger factor. Let's say that you know that 1 hour, has 3,600 seconds. You can make your life easily by doing it either using this factor or doing it individually. Yes, you can do it individually as well. You can do it one by one and then go to the final answer. But here it's showing that you can use the chain to finish up your work at once. One line is enough. Okay, can we move? Okay. Okay, now the chapter itself has finished, but there is one important thing we should go over, which is the significant figures and decimal places. My notes over here doesn't have it, so I'm gonna say it. I'm gonna try to explain it, and then the next slide will have a picture from the book, which will I think it will help you a lot. So, significant figures. It's a very common issue here in this chapter, and so I'll try my best to explain it. So, let's say that we have this number 3.16. So this number has 3 significant figures, because as you can see, the numbers are good. We don't have any zeros, and we don't have anything suspicious. So this number will have 3 significant figures. Let's say that, for example, we have, give me a second, I have a picture over here. Okay, let's say that we have 0.00316. Now this number, as well as the number above it, have 3 significant figures. Why? Because in the rule, any 0 to the left is not considered significant. So whatever your number is, you might have a number like 0.02. You might have a number like this, and you would say that this number has only 1 significant figure. Why? Because any 0 to the left is considered non-significant. Yani take this as a rule. Take it as a rule of thumb. Let's say that you have 3.106. Now this number over here will have 4 significant figures. Why? Because we have normal numbers, and our 0 is in between 2 normal numbers. So the 0 over here is really important. Yani if you take the 0, it will be a different number. So since your 0 is in the middle of 2 normal numbers, it will be considered as significant. So let me just highlight it over here. So this is one case where we have normal numbers. This is another case where we have zeros to the left. And this is also another case where we have a 0 in between normal numbers. Now the final case, which is a little bit sketchy, because the book is following something and the rest of the world is following something else, which is if you have zeros to the right. So for example, if we say 3,000. Okay. Now, if you look at this, some might say that the zeros to the right are not significant, and some might say they are. But in our book, please make sure of this, that this number will have 4 significant figures based on our book. Our book says if we have zeros to the right, it is called, or it is considered significant. So let me show you the picture from the book. It has a lot of words, but be patient. We will take it slowly and digest it, يعني حبة حبة. So let me read over here and go over it. So it says that, suppose that you work out a problem in which each value consists of 2 digits. Those digits are called significant figures, and they set the number of digits that you can use in reporting your final answer. Yeah, this is also one thing that we have to take into consideration. Let's say that you have 2 numbers, 4.2, let's say, and then 4.33, and then you do whatever operation, whether it's multiplication or division or anything like that. Here in our book in physics, you should pay attention to significant figures. Your answer over here should have the least amount of significant figures. Least amount. What do I mean by that? So this guy over here has 2 significant figures. This guy over here has 3 significant figures. So your final answer should have only 2 significant figures. Okay. It says it over here as well. It says, with data given in 2 significant figures, your final answer should have only 2 significant. So it's depending on the least number. However, depending on the mode of setting of your calculator, many more digits might be displayed. Just don't neglect this one. Okay. Also, he's saying over here in this book. Yeah, I'll give an example. Let's just finish reading over this. It says in this book, final results of calculations are often rounded to match the least number of significant figures in the given data. However, sometimes it is given an extra. Also, it says, let me see. So, for example, if you can look at this number over here, 11.3516. When he wanted as 3 significant figures, you will look at the number next to the 3, which is 5, and then you will add 1. So it will be 11.4. Okay? And if you have this different number, which is 11.3279, if you want it as 3 significant figures, it will be only 11.3 because the 2 over here is less than 5. So you won't add. Okay? I believe this one is the most important one, this side over here. It says, when a number such as 3.15 or 3.15 times 10 to the 3, just like I told you earlier, is provided in a problem, the number of significant figure is apparent. But how about the number 3000? So we talked about the 3000. Since we have zeros to the right, they will be considered as significant only in this book. Okay, the last one is for decimal places as well. It says, don't confuse significant figures with decimal places. So he will give you this example. So you have 35.6, you have 3.56, and you have 0.00356. All of them has 3 significant figures, but the only difference is in decimal places. So what is a decimal place? It is the digits after the decimal. So if you can look at the first one, if you can look at this guy, we only have 1 number after the digit. If you can look at this guy, we have 2 numbers after the digit. And if you can look at this guy, we have, I don't know, 5. So they all have 3 significant figures, but their decimal places is different. So this is the thing you should be looking at. Someone asked for an example for significant figures. Let's see that we have, let's say that we have 5.2, for example. No, 5.73. And then you have the number 2.44, let's say. So this number has 4 significant figures, and this number has 3 significant figures. If I do this calculation in my calculator, if I put all the numbers just like they are, it will give me this 2.161065574. But if you put this answer in the quiz, I most likely he will give you a bad idea. So what should you do? What should you do in this situation? You should look for the least amount of significant figures. So the least amount over here is 3. So your final answer should only have 3. So let's see, 2.16. What about the number after the 6? Since it's less than 1, we don't add. So it is only 2.16. Imagine the number in our calculator had a 5 over here. Imagine it had a 5. So if I want to get the final answer, it should be 2.17 because we have to round off to get our 3 significant figures. Okay? Is that good? Okay. Okay. خلاص then. If you understand this one, if you understand decimal places, then I believe our chapter is good. We will go to the selected problems. Just give me a second to prepare it. And they are straightforward, and hopefully we can finish from them and go to the other chapters quickly. Okay, do you see what I see right now? Do you see the painter? Okay, good. Okay, so this is the first question. It is one of the recommended problems. I don't know if your doctors gave you the recommended problems or not, but I have those from the past semesters, and normally they always go and solve those problems as a way to make students understand. So this is basically this is problem. Where is this? So this is problem 4. I don't know the page, but yeah. So the problem is straightforward. You just have to pay attention to the conversion factors given, and then we would solve upon them. So the question is saying space in this book was generally done in units of points and picas. So we have some quantities here called points and picas. So he gave you the first conversion factor, which is 12 points equal to 1 pica, and 6 picas equal to 1 inch. And then he's saying if a figure was misplaced in the page, proofs by 0.7. Meaning of this, عند حرف مثلا أو عند أي figure معين وصار له misplacement، يعني ما انكتب في مكان معين. And this misplacement was by 0.7 centimeters. And he's asking what was the misplacement in picas and in points. And so basically we have to convert the centimeter to picas and to points. So I will solve this, and then if you have any questions after I solve it, we will go over it. Okay, so part A here is saying he wants it in picas. So we start by 0.7 centimeters, and then we have to change the centimeters based on what we have. So the conversion factor here is 6 picas equal to 1 inch. So we have to first change the centimeter into an inch. And if you can remember from the slide, the conversion factor was that 1 inch is equal to 2.54 centimeters. Okay. Wow, what is this? Now, continuing. So now, since the centimeter is in the denominator, it will go, and then we will use our final conversion factor, which is the given in the question, that 6 picas over 1 inch. And then that's it. You will find your answer over here. So let me just use my calculator quickly. This will be, since the question is not talking about any significant figures or anything like that, it is up to you to use anything. The calculator is giving me 1.65. You can round this off and you can say it is 1.7. But really, if you want to be accurate, here we have one significant figure, and here we have 3. So your answer should be in one significant figure. But since the question is not asking about it, it's okay. You can neglect it. So basically, I just used the conversion factors to do my calculation. Okay, the second one is saying in points, and so right now we have to change into points. You can do all of this again, or you can use the answer we just did. So you either use 1.7 picas and then just multiply it by the conversion factor that is given, which is 12 points over 1 pica. Or you can type the whole thing again and get your answer, which will give you basically the same thing. So put this in the calculator. This will go with this. Your answer should be 20.4 points. And that's it. This is basically the first question. It's just a matter of using different conversion factors. And I hope it's clear. Okay. Okay, let me prepare the second question. Let me make sure. Okay. Okay, so this question is question 9 from your book. Okay, so the question is saying, a cubical object has an edge length of 1 centimeter. So let's take this one by one. It's saying a cubical object. So we have a small object, which is the size of a cube, and the edge is 1 centimeter. Now he's saying if a cubical box contained a mole of cubical objects. So now we have a bigger picture where we have a huge box that has 1 mole of cubical objects. Find the edge length of that box. يعني بالعربي عندي بوكس على شكل مكعب وداخله 1 مول of مكعبات أخرى. طبعا احنا نعرف الإدج بس حق المكعبات الصغيرة، ويبي يعرف الحين الإدج حق المكعب الكبير. So basically this question will be is heavily based on the idea of volume. Okay, so now the small object is 1 centimeter in length. If I want to find the volume of it, it is basically 1 times 1 times 1, and we will get 1 centimeter cubed. Okay, now since we have 1 mole of object inside this box, so I'm just going to multiply 1 mole by this volume so I can get the total volume. We know that 1 mole is 6.02 times 10 to the 23. I will multiply this by this volume, which is 1 centimeter cube, and then I will get 6.02 times 10 to the 23 centimeter cubed. كل اللي سويته الحين اني ضربت عدد المكعبات في حجم مكعب واحد. احنا حسبنا ان حجم المكعب الواحد هو 1 سنتيمتر كيوبد، وهو قال لي اصلا عندي 1 مول of cubical objects. خلاص كل اللي سويته اني ضربت المول في الفوليوم. اي المكعب هو بيسكلي لما نتكلم عن edge في مكعب هي الطول العرض والارتفاع. يس. الحين جبت انا وشو جبت ال total volume. Now I have the total volume of all objects inside that cube. Now let's say that I will ask you this: if this side was x, now what will be the volume of the big box? What would be the volume? You tell me. If my side was x, what would be the volume of the bigger box? Okay, I'll help you out. If we're talking about a cube and someone is telling you this is x, then for sure this one is also x and this one is also x. Yes, thank you. Yes, exactly. So the volume of the bigger box, or the volume of any cube outside, will be 1 side to the power 3. Now here we got the total volume, so we already know the total volume. How can we find the side? How can we find the side itself? We will just do the following. We will use our volume, and then we will get its third cube. Yes, exactly. It's the root. It's the cubic root. Okay. And now you just plug this into your calculator, and you could find the answer right away. It will be something very huge, since our volume is in centimeter cube, then our side would be in centimeters, so it is this number. Yes, thank you. ان شاء الله فاهمين فكرة السؤال. فكرة السؤال بسيطة جدا. يقول لك عندك مكعب وداخل مكعب كبير. المكعب الصغير اعطاك الفوليوم حقه، او اعطاك السايد وانت تجيب الفوليوم، وبعدين قال لك المكعب الكبير فيه 1 مول اوف مكعبات. فانت ايش تسوي؟ تضرب عدد المكعبات في الفوليوم حقهم، وبعدين تاخذ الروت الثالث عشان تجيب السايد حق the bigger cube. Did you all understand this one? Okay. Let me just save it and go to the next one. Come on. Okay, let me prepare the next one. So this is on 21 from your book. Okay, the problem is saying a 3.5 centimeter cube volume is occupied by a wood piece of mass 9.05 grams. Find the density of this piece of wood, taking significant figures into considerations. Okay, now since we have we are given everything, and we're just the question is just asking us to find the density, and he wants its significant figure. So before doing anything, we should change to our SI units. If you remember from the beginning of the lecture, we talked about the SI units, which are basically the meter, the kilogram. So if you have anything besides those, you should always convert. So we will start by converting 3.5 centimeter cubed. We shall convert this to meter cubed, and so you should keep in mind that 1 meter is equal to 100 centimeters. And so 1 meter cubed will be 100 to the power of 3. Okay, so you use the conversion factor, so 3.5 centimeter cubed, and then you will multiply this by our conversion factor. Okay, and then we will get our answer. So you just have to play the right conversion factor over here, and then if you put this into the calculator, you will get 3.5 times 10 to the minus 6 meters. Okay, and then you have your mass, which is 9.05 grams. You will multiply this by the conversion factor, which is 1 kilogram by 1,000 grams. You will do the skip over here, and then you just divide and find your mass in kilograms. Okay, now we have those two answers. He's asking about the density. Density raw is equal to mass by volume. Our mass is 9.05 times 10 to the minus 3. Our volume is 3.5 times 10 to the minus 6. And now, just like I told you before, the number up above, this number has 3 significant figures because the 0 is in the middle. This number has 2 significant figures, which is very obvious. When we do our calculation, we should always follow the least amount of significant figures. And so if you plug this into your calculator, it should tell you it will give you a huge number, but then basically it will give you this number. It will give you 2.585 times 10 to the 3. But we want it in our significant figure, which should be in 2 only. So we look at the digits over here. We see we have 8, which is greater than 5, so we should add 1 over here. So our final answer would be 2.6 times 10 to the 3. And the unit for density is kilogram per meter cubed. I hope everyone is good on that. Okay, if it's clear, then we'll be moving on. Okay, let me prepare the other question. This is question 23. Okay, so the question is saying a 2 meter by 3 meter plate of aluminum. So imagine that this is the plate of aluminum, and this is 3, this is 2. It has a mass of 324 kilograms. What is the thickness of the plate? So he's asking about the thickness. So again, excuse my drawing, but you can imagine that this is the plate of aluminum. He basically gave you the width, and he gave you 2 sides, and he's asking about the third one. And then you could see here he gave you the density. So again, we're using the law of density over here, which is mass by volume. And then since we want the thickness, يعني we're talking about the third dimension when we're talking about volume, because volume would be thickness times width times height. So he gave you the density and he gave you the mass. This is basic mathematics. Just divide the mass by the density to find the volume. So the mass is 324. And then your density is 2.7 times 10 to the 3. You can get your volume. Let me put this in the calculator. 324. Okay, since you have done it, I won't question your decision. 0.12 meter cubed. Okay, now you're just looking. Is that? Density equal mass over volume. So the volume is mass by density. Yeah, that should be good. What? Oh, there's a mistake. Rho V equal M. V will equal to M for Rho. I think there is a mistake in this question. Just give me a minute over here. There isn't? Okay, so probably you solved it. There isn't? Okay, then we'll see what we'll get. Okay, since okay, then we have the volume, which should be 2 times 3 times the thickness. Now, since we have our volume 0.12, then this would be 2 by 3 by the thickness, and then the thickness should be 0.12 divided by 2 times 3. Is that what I think it is? Okay. Yeah. Apparently, it is correct. Okay, so we just found the volume. I don't know why my head messed up. We just found the volume, and then we just applied this rule, which is basically saying that the volume is the width times the height times the thickness. Yeah, it happens to the best of us. Excuse me. So this is your thickness. This was the final volume, and then these are it was given from the question, and we're looking for this guy. So the thickness is equal to 0.02 meters. I don't think I need to ask if this is clear or not, because apparently all of you know that. So moving on. Let me prepare the final question for this chapter, and then we will take a small break and go for the other chapter. Okay, let me make sure you can see that. Okay. This is question 27. Yes, hopefully all of this would be in Blackboard. Yes. Question 27. Okay, so it's a really straight question. It says a grocer's balance shows the mass of an object as 2.5 kilograms. And you have two gold pieces of masses 21.15 grams and then 21.17 grams. And he's asking, they are added to the box. What is the total mass in the box to the correct number of significant figures? So right away, before starting, you should know that we are using SI units. And so we should change our gram to kilogram. Yes, exactly. And so this is basically, you just divide, and then this should be 0.02115 in kilograms, and this should be 0.02117 kilograms, and you already have this in 2.5 kilograms. So looking at this, you still have 4 significant figures over here. Here you have 4 significant. Here again, 4 significant. And this guy is only 2. So when you want to find the total mass, you should add and then make sure that you would be in the correct amount of figures. So if you put this in the calculator and add, it will give you this number, 2.54232. But since we're talking about the correct number of significant figures, this should be as 2.5 kilograms. That's it. Excuse me. So this question is straightforward. If anyone has any doubt about it. If not, then this was the last question in this chapter. We will take a break of 3 minutes, and then we'll come back to finish the next chapter. Okay, 3 minutes has passed, and this would be a lengthy one, so hopefully we'll be able to finish it before 9 o'clock, and we'll see about that. So chapter 2 is talking about motion along a straight line. We will have some different things to talk about over here. Okay, so we'll be talking about, where is this? So we're talking about position, displacement, and average velocity, instantaneous velocity and speed, acceleration, constant acceleration, and free fall. So going over them one by one. Basically, when we talk about motion, it's the study of motion is called the kinematics. The word kinematics means that we are only interested in where it's going and how fast it's going there, and we're not interested about the forces. We'll see the definition in just a few slides. Examples of motion: when the Earth is orbiting the sun, and a roadway moves with the Earth's rotation. So basically, a general motion. Here is the definition of kinematics. I believe this one could be, you should know this. This definition, you should know it. Don't memorize it totally. I mean, you don't have to write definitions, but you may find it in املأ الفراغ ولا صح وخطأ ولا حاجة كذا. It happened before and it could happen again. So it says kinematics is the classification and comparison of motions. In this chapter, we restrict motion in 3 ways. Motion along a straight line, and then we discuss only the motion itself, not the forces causing it. And we always consider our objects as particles, which means a point-like object. Yani, even if you're talking about a car or anything like that, you will treat the whole thing as one point, which is the particle. Moving on, here we're talking about position. General ideas: position x of a particle on a x-axis locates the particle with respect to the origin. So whenever you're talking about position, you should have an origin. So if we're talking about this line over here, our origin is the 0. Here it says the 0 point. If you're going from your house to the university, your origin or your 0 point is your house, which is the start of your motion or your start of your movement or anything like that. Now here it says position has a sign. It has a sign. The position is either positive, negative, or 0. So how do you have a positive direction when you're moving in the direction of increasing numbers? How do you have negative direction if you're going the opposite to the positive, or basically in the decreasing numbers? And your 0 position means that you're not moving, you're standing still at the 0. I believe this one is all of this is straightforward. But we have our first topic here, which is the displacement. The definition basically is the change in position. So the change in position, delta x is equal to x2 minus x1. So the final position, wherever you stop, or your final destination, your final position, minus your initial. The SI unit for displacement is meter. Here we have some examples. You should understand those because let's look at them. So it says from x equal to 5 to x equal to 12. So this is your initial, this is your initial, and this is your final. So if you want to find your displacement, delta x would be 12 minus 5, which is 7, which is positive because your sign over here is positive. If we're looking at the second one, from x equal to 5 to x equal to 1, so when you're لما طبق المعادلة, you will have 1 minus 5, which will equal to minus 4. So this is negative, so it's negative direction. And now this is interesting, the last one, if you can look at it. It says you started from x equal to 5, you go to x equal to 100, and then you come back to x equal to 5. So this is your initial, and this is your final. And when you put them in this equation, your result will be 0. So your displacement, الإزاحة, would be 0. So it says here, It involves only the initial and final positions, not the positions in between. Okay. Again, we have another concept here. It says displacement. It says displacement is therefore a vector quantity. No, I mean, it's the same concept, but now we're talking about vector quantities. We should all know that when we say vector, we means it has a direction and a magnitude. الفيكتور هو الشيء اللي عنده اتجاه وله قيمة, direction and magnitude. So it's either along a single axis given by a positive or negative, and then a magnitude, it's either length, distance, or in this case it's meters. Now, ignoring sign, we get its magnitude is the absolute value. So whenever someone is saying, give me the magnitude of something, you forget about the sign and you just give him the number without the sign. So here, it's a little bit cut out, but you can see it. It says the magnitude of delta x equal -4 is only 4. So you could be going a negative displacement, but the magnitude is 4. Because the sign over here, الإشارة هنا بس بتدل على الدايركشن, هو أنت رايح بالسالب ولا أنت رايح بالموجب. Okay, here we have a checkpoint. It says here are 3 pairs of initial and final positions. عطاك قيم حق initial و final respectively along an x-axis. Which pair give a negative displacement. يعني يبيك بس تطبق المعادلة وتشوف أي pair من ذول البيرات يعطيك إزاحة سلبية. So if you can look at them, we have -3 + 5. So if you put them in the delta x equal x2 minus x1, هنا عندك 5 minus -3, so this will give you 8. So this is not negative. But if you try B and C, if you can see they are here, -7 minus -3, it will give you -4, and then -3. This guy, -3 -7, it will give you -10. So this is negative displacement. Basically, this is a straightforward application of the law itself. Another topic over here, which is the average velocity. Whenever someone is saying average, then you should pay attention to the law. It will have this sign. It will have the delta sign. So let's read the definition. It says, average velocity, or V average, is defined as a displacement over the time duration. So this guy over here, displacement over time, delta x by delta t. You should memorize this. This one is saying the average velocity has the same sign as the displacement, because time cannot be negative, so this guy is always positive, but your displacement, it could be positive or it could be negative. So your V average will depend on it. Now here it says average velocity has a unit of distance per time, يعني meter per second. SI unit for average velocity is meter per second. Okay, it's here. The reason it says distance over time, because you could be using other notations for distance, which could be inch or anything like that. But since we're talking about SI unit, then it is meter. Okay, here you should know this, by the way. On a graph of x versus t, which is position versus time, the average velocity is the slope of the straight line that connects any 2 points. So if you can take a look over here, we have here xm, position, and here we have ts, time in seconds, and we have different points, and when we connect them with this line, the slope of that line will be our V average. Again, you can know this by, if you remember the law for slope, قانون السلوب أو الميل هو كان فرق الواي على فرق الإكس. يعني فرق المحور الواي وهذا محور الإكس. الفرق على فرق الواي على فرق الإكس. هنا عندنا في الرسمة محور الواي سميناه البوزيشن الإكس، فطلع معنا دلتا إكس، والإكس أكسس هنا طلع معنا الوقت دلتا تي. أوكي، فخلني أمسح دي عشان لا تعور راسكم. It's basically the slope is your average velocity, since you have position versus time. So always when you go to the question, what I'm trying to say here, when you find a graph in your question, make sure to look at those numbers, those units. When you know those, you can find what the graph is talking about. Okay, one last thing we've missed over here. Average velocity is a vector quantity because it has a magnitude and a direction. So positive slope means positive velocity, negative slope, negative velocity. We all know that if the graph is like this is positive, but this is positive slope. And if the graph is like this is negative slope. This is basic mathematic rules over here. Okay, moving on. Average speed, we're talking about something similar to average velocity, but now it's average speed. It's saying it's the ratio of the total distance covered to the total time interval. So if you remember, our V average, our average velocity, was the position, the change in position over the change in time. But now your speed is depending on the total distance. Now here it says average speed is always positive. There is no direction. It is a scalar quantity. Okay, now we come to the second concept, which is the scalar components or scalar quantities. It does not carry any sense of direction. So whenever someone is saying أنا كنت أمشي في سيارة 120 مثلا 120 كيلو في الساعة, you won't understand anything from this because it's a scalar quantity. It's not a vector quantity. Scalar quantities only have magnitude with no direction. It says here SI unit for average speed is meter per second. Again, same thing. An example, a particle moved from x equal 3 to x equal minus 3 in 2 seconds. Then the average velocity, we will use this guy over here, which is the final minus initial. So minus 3 again over 2, you will have minus 3 meters per second. But your average speed would be the total distance. Now, how will you get the total distance? You can look here above. You have this line. This is your 0, your origin. This is your x equal minus 3, and this is your x equal to 3. So how do you get the total distance? It is the distance from this guy to this guy, this whole thing. So I think you all agree that this distance is 6. So when you apply this law, you will have 6 divided by 2, which will equal to 3. So now you can find the difference between the average speed and the average velocity. The average velocity is a vector quantity. It has a direction and magnitude, but the average speed is only scalar quantity. It has no direction whatsoever. Okay, we're good. You all are here, mentally and physically. Okay, good. Moving on. Okay. Another concept over here is the instantaneous velocity. Whenever we say instantaneous, it's the same thing as not saying it. So we can say instantaneous velocity or just velocity. V is the velocity at a particular instant of time or a single moment of time. So the definition is you're taking the limit when your time goes to 0 of your average velocity. Okay, this will give you that the velocity, the instantaneous velocity, is the derivative of the position by time, or the derivative of displacement by time. So you should know that V is equal to dx by dt. خلاص, you should memorize this. Now it is you can read over here. It says it is the time derivative x. It is a vector quantity. The sign of the velocity represents its direction. SI unit for instantaneous velocity is meter per second. So yeah, whenever we're taking the limit of something, it will give us the derivative. Okay. Here it says speed is the magnitude of the instantaneous velocity. So for example, if he's saying we have a velocity of 5 meters per second and a velocity of minus 5 meters per second, both of them have a speed of 5, because again and again, speed is a scalar quantity and velocity is a vector quantity. So yes. If we look at this checkpoint over here, it's an interesting one, pretty easy. It says the following equations have the position x of t of a particle in 4 situations. He's saying in each situation, x in meter and t in seconds, and the time is greater than 0. Okay, so we have situation 1, 2, 3, and 4. The question is saying, in which situation is the velocity v of the particle is constant? Now, he has given us an equation, and how do you find the velocity? We just learned that the velocity is the time derivative of the position. Okay, so we just get the derivative. So here x, if we get the derivative, it should be v. 3t, when you get the derivative, is 3, minus 2 is 0. So subhanallah, we get v is equal to 3. So since it has no variable with it, so it is constant. Okay, let's try the second one. The second one is saying x equal to minus 4t squared minus 2. If we try to get the derivative, so this x would be v. Basically, it would be dx by dt, but you can write it as v. Yeah, I can repeat it. Okay, I'll repeat it بشوي شوي. السلايد اللي قبل شوي مشت كانت تقول ان الانستنتينيوس فيلوسيتي اللي هي الفي عباره عن الديريفاتيف دي اكس باي دي تي. خلاص ابيك تحفظ ان الفيلوسيتي هي الديريفاتيف حق الاكس with respect to time. بس الحين في السؤال عطاك 4 حالات 1 2 3 and 4. السؤال يبيك تشوف الحالة اللي فيها الvelocity constant. In which situation is the velocity v of the particle constant? فأخذنا أول وحدة قلنا خلينا نجرب x equal 3t minus 2. الديريفاتيف ايش هو؟ الاشتقاق. تذكرون الاشتقاق ولا لا؟ كيف تجيب مشتقة؟ إذا عندك for example if you have x to the 2 x squared يعني المشتقة حقتها 2x. وإذا عندك x 3 المشتقة حقتها 3x تربيع. تنزل ويعني تنزل الرقم مثل ما هو وتنقص. إيه، فهذا هو الديريفاتيف، هذا هو الاشتقاق. فكل اللي سويته اني حولت الايكويشن اللي عندي، حولتها من x حولتها الى v. اقول له dx by dt، يعني اجيب المشتقة. ايش مشتقة ال 3t؟ بما ان ال t الاس حقها 1، اذا الثلاثة راح تظل لوحدها. وبما ان minus 2 is just a number, so the derivative is 0. So we don't write it normally. So the first one, the first case، هذا البوزيشن هذا اعطاني this velocity 3 which is constant. ما عندي رقم، ما استغفر الله، ما عندي time معها ولا عندي variable ثاني، بس 3 لوحدها. خلاص اذا هذه الvelocity constant. الحالة الثانية، كيف الفرق بين الvelocity الأول والثاني بالسؤال؟ ما أفهم سؤالك. هو بيقول لك يعني بيقول لك أبي أما average velocity أو أبي velocity. الافرج راح تستعمل قانون الافرج اللي هو دلتا اكس باي دلتا تي. هذا في افرج. واذا يبي الفيلوسيتي العادي تجيب الديريفاتيف. كذا اوكي؟ اوكي طيب خلينا نكمل نشوف ثاني واحدة. The second one is saying x equal minus 4t squared minus 2. الحين نبي نجيب المشتقة حق هذه، so dx by dt. راح نجيب الاشتقاق، يعني راح نضرب الاثنين في -4 راح يطلع لنا 8، والتي راح تظل لاني بس بنزل اس واحد، والماينس 2 راح تختفي. هنا الفيلوسيتي حقي طلع minus 8t. This is not constant. ليه؟ لان عندي variable الزمن مع رقم. يعني اقدر احط لك اي زمن، اقول لك والله at t equal 2 seconds راح يصير في velocity معين، at t equal 10 seconds راح يصير في velocity معين. اذا هنا this is not constant. Okay, if we take a look at the third case, x equal 2 divided by t squared. Now to make our life easier, you can write this as x equal 2 t minus 2. بس شلت الأس من تحت وركبته فوق. فإذا عندك أس في المقام، إذا بتركبه فوق راح يصير بالسالب. فخلاص نسوي الحين العملية اللي نعرفها اللي هي dx by dt, and we will find that it will equal to minus 4t. الحين سالب 2 بشيل منه واحد راح يصير سالب 3. أرجع أكتبها مرة ثانية بطريقة طبيعية راح يصير سالب 4 على t cubed. خلاص بما أن عندي variable مع الرقم, then this velocity is not constant. So case 2 and case 3, they are both not constant. Let's look at case 4. شلون صارت minus 3. Okay, I'll repeat it again. Okay, x is equal to 2 over t squared. المفروض انك فهمت ان هذه حولتها الى t اس minus 2, بس شلت الاس من تحت وديتها فوق. اذا وديه فوق يصير سالب. اذا باخذ المشتقه الحين dx by dt, القانون اللي نعرفه اذا عندك ax power b, اذا بيجيب المشتقه راح يصير a b هنا x وهنا b minus 1. هذا قانون الاشتقاق, هو انك تنزل الاس وتطرح منه واحد. فهنا اذا بشتق راح يصير سالب 2 في 2 سالب 4, وبعدين السالب 2 بشيل منه واحد راح يصير سالب 3. عشان كذا طلع لي الأس سالب 3. وبعدين برجع أكتبها بطريقة طبيعية, بنزل التي تحت فطلع لي سالب 4 على t cubed. Are we good? Okay. وأجين بما أن عندي variable, إذا ما دام عندي t مع الرقم, إذا هذه الvelocity ما هي constant. So this case number 3 is neglected. If we try case number 4 really quickly, x is equal to minus 2. الاشتقاق حق الرقم دائما يكون 0. فبما أن عندي بما أن عندي 0 ف it's constant, الصفر ما راح يتغير. فإذا ناظر هنا الجواب يقول لك situation 4. So مثل ما طلعنا أن situation الأول والأخير اثنينهم فيهم velocity constant. الجزء الثاني من السؤال يقول لك in which is v and the negative x direction. في أي من الحالات طلع معنا ال v بالسالب. الحالة الثانية والثالثة اللي حليناها. ليش؟ لأن the second case أعطانا الجواب v equal to minus 8t, والحالة الأخيرة أعطتنا ال v equal minus 4t power 3. So اثنينهم they have a negative sign, so it is a negative direction. ليش؟ لأن we said earlier أن الساين حق velocity is dependent on the sign of x. فبما velocity عندي سالبة, إذا الx حتما راح تكون سالبة. Okay, are we good on this checkpoint, all of us? Okay, moving on. طيب, another example of the graphs where I don't know if you can see this correctly. If you can't, let me try to zoom. One question, if I zoom, do you see the zoom or it's only with me? Is the text zoomed right now? It's not. Okay, you can see in the top left ناظروا يسار فوق في ضغطة كذا كانها وش اسمها هذه العدسة المكبرة. Yes, exactly, you can zoom it. Okay, so if you can zoom to the graphs over here, so that I just want to show you one thing. Just a moment ago, I told you, whenever you have a graph, always make sure that you look at the units. So this graph is x versus t. Okay, so when you take the derivative, it will become v versus t. V versus t. So let's read over here. It says the graph shows the position and velocity of an elevator cab over time. The slope of x of f of t, and so also the velocity v is 0 from 0 to 1 and from 9 and so. Okay, فيقول لك ان عندي velocity 0 في هذه المنطقة، فلما اخذ الديريفاتيف وارسم الجراف مرة ثانية راح تطلع لي الvelocity as a constant line. Since it's constant يعني ما تتغير. Here it says during the interval BC the slope is constant and non-zero, so the cap moves with constant velocity. خلاص من تصير سرعتك ثابتة، تصير الرسمة عندك في الجراف خط مستقيم ثابت. أما إذا عندي هنا مثلا إذا ناظر ذي الجهة you can see that the graph is increasing, so the velocity is increasing. But once it reached this point, it kept on a straight line on number 4. Okay, so this is what I wanted to show you. Okay, you can zoom out right now. I just wanted to let you see the letters themselves. And always remember إذا عندي جراف دائما يكون الواي versus x، دائما الواي axis versus x axis كذا الكتابة يعني. فأول حرف يطلع لك يعني إذا يجيك سؤال يقول لك مثلا ارسم لي x versus t، دائما أول حرف بتشوفه هو راح يكون الواي axis، يعني ارسم لي x versus t، خلاص تعرف ان الاكس راح يكون يعني البوزيشن. لما اقول x هنا اقصد البوزيشن راح يكون في الواي اكسس. لما يقول لك ارسم لي v versus t خلاص الفيلوسيتي تكون في الواي اكسس. يعني بس خذ كقاعده ان الواي اكسس دائما يذكر اولا. Okay, moving on. We come to another concept, which is the acceleration. First, we talk about the average acceleration is the ratio of the change in velocity over the change in time. So A average is delta V by delta T. And the instantaneous acceleration or only acceleration is the derivative of velocity with respect to time. So just to remember, we have V average, which is delta X by delta T, and then V itself, dx by dt. And now A average is delta V by delta T, and the normal A is dV by dt. Now you can imagine what we will see in the next slide. You can see that the acceleration itself is dV by dt. If we take V outside, V itself, we just knew that it is dx by dt. So if you want to get the acceleration, you can get it straight away from the position. You take the derivative 2 times. بمعنى الآخر إذا عندك معادلة فيها x يساوي ما أدري إيش خربطة، وقال لك جيب لي velocity، راح تسوي اشتقاق للمرة الأولى. إذا يبي acceleration راح يسوي الاشتقاق مرة ثانية. This is the gist of it. This is what it is. Okay, so the acceleration is called the second derivative of the position. ليه؟ لأن في رقم 2 هنا. Again, acceleration is a vector quantity. عرفنا أن vector quantity, it has a direction and magnitude. Positive sign means it's in the positive coordinate direction. Negative means it's opposite. The unit is this by time, and the SI unit for us, it is meter per second squared. Okay, now there's something over here. Just let me check the next slide. Okay, no. I will talk about this now. It says if the signs of the velocity and acceleration of a particle are the same, the speed of the particle will increase. And if the signs are opposite, the speed will decrease. I will talk about this at the end of these slides. So because I kept a clear page for it. So for now, let's leave it and we'll talk about it later. Here it's talking about the acceleration. I don't know if you've seen pictures like this before. This is basically الاختبارات اللي سووها الامريكان وغيرهم على الطيارين واللي يركبوا الصواريخ وذا، يحطوهم في مقعد ويحركوهم بسرعة عالية جدا، يعني بتسارع عالي عشان يشوفوا كيف الجسم how the body reacts with acceleration. اللي يبيكم تعرفون ان here it says the magnitude of acceleration falling near the earth، يعني انت قاعد تطيح باتجاه الارض. We all know this, which is 9.8 meter per second squared, and it is often referred to as G. So this should be known to everyone that G is equal to 9.8 meter per second squared, which is the acceleration of the gravity. Again, he's saying here that we can express acceleration in terms of G. يعني إذا عندك acceleration تقدر تحوله وتقول والله هذا الاكسلريشن حقه 2G ولا 3G ولا 4G like this يعني. So it says if a car with velocity v equal minus 25 meter per second is braked to a stop in 5 seconds. أعطيك الvelocity أعطيك التايم فتقدر تحسب الاكسلريشن، راح تقسم بس. We all know that A average is equal to delta V by delta T. فأعطاك هنا minus 25 أعطاك هنا 5 بتقسم راح يطلع لك الاكسلريشن is like this. So here it says it's braking, and so the acceleration is positive but the speed has decreased لأنك أنت قاعد تضغط البريك. And that's it. يعني acceleration can be expressed in units of G. Again, here it's saying 1G is equal to 9.8 meter per second squared. Okay, this checkpoint is also related to the thing that I want to talk about next. Okay, I can talk about it right now. Let me go to the slide. Let me go to the empty slide and I will try to explain it. Just give me 1 second. Okay. So what he's saying right now أن عندنا velocity واcceleration وspeed. بشكل عام إذا أنا الvelocity حقتي موجبة والاكسلريشن حقي موجب، السرعة حقتي راح يصير لها increase. لا إله إلا الله. Okay, let me write that again. If I have positive velocity and positive acceleration, my speed will increase. If I have negative velocity and negative acceleration, my speed will also increase. Okay. تقدروا تتخيلوا يعني هذه situations, but if you can't, يعني just memorize this because normally this comes as a conceptual questions in quizzes and midterms. بشكل عام إذا الإشارات نفسها السرعة راح تزداد، إذا الإشارات مختلفة السرعة راح تقل. Okay. So this is what I wanted to tell you. وتقدر تتخيل يعني ال situations you have سرعتك قاعد تمشي 100 مثلا وانت قاعد تضغط على البنزين، يعني السرعة حقتك راح تزداد. For negative velocity it is only for the direction, and so it's the same thing. So just memorize it like this and you should be good to go. Memorize that if you have the same signs then your speed is increasing, if your signs are different then your speed is decreasing. So if you can go back to our checkpoint, it is mainly talking about this. It says a wombat. Wombat is basically a fighter jet or something like that. A wombat is moving along an x-axis. What is the sign of its acceleration if it's moving؟ الحين قاعد يتكلم عن الإشارة حق الاكسلريشن. if it's moving in a positive direction with increasing speed. طيب احنا قلنا متى يصير increasing، متى يصير السرعة increasing if we have the same signs. فهنا يسألك قال لك شو اسمه it's moving in the positive direction. إذا إيش الأكسلريشن حقي؟ راح يكون موجب عشان يكون نفس the same sign. Yes. B. Now being in the plus increase. Yeah, it's increasing. He's talking about increasing speed. ف نفس الكونسبت هنا. Part B is saying in the positive direction. أنا قاعد أمشي في ال positive direction with decreasing speed. إيش راح يصير في الأكسلريشن حقي؟ قاعد أمشي okay. Okay, exactly. Okay, so I think you understand the concept over here. Positive direction, decreasing speed, so the sign would be different. Negative direction, increasing speed. إذا بما أن عندي increasing لازم أستعمل نفس الإشارة فيكون عندي negative. The negative direction with decreasing speed, decreasing وعندي سالب لازم أقلب الإشارة فصارت موجب. Please tell me you all understand this. I feel like I didn't give it its يعني ما أعطيتها حقها. Did you all understand this one? Okay, good. Okay, let's move on then. Again, if you want to zoom over here, if you want to zoom on the graphs itself, I want you to see that here we have v velocity and here we have time, and then when we take the derivative, we will have acceleration here, and the time would be itself. So let's read this over here. It says the graph shows the velocity and acceleration of an elevator cab over time. When the acceleration is zero, لما ما يكون عندي تسارع, okay, for example interval BC, velocity is constant. فشوفوا هذا الانترفال هنا BC, هذا الانترفال BC, okay, التسارع حقه أصلا صفر. ننظر هنا، لما ننظر هنا تحت التسارع صفر، يعني ما عندي تسارع، فالسرعة حقتي تظل ثابتة. Now here it's saying when the acceleration is positive, AB, فالvelocity will increase. So هنا عندنا AB الاكسلريشن حقي راح يرتفع، راح يصير بوزيتيف. عشان كذا نشوف في الجراف حق الفيلوسيتي ارتفع كذا، صعد فوق. So it's obvious now. Positive acceleration يعطيك زيادة في السرعة. Acceleration zero سرعتك ما تتغير، تظل ثابتة. Again here when acceleration is negative، فهنا عندي negative acceleration يعني قاعد أتباطأ، فسرعتي راح تقل. You can see it in the velocity graph. Okay, you can zoom out now. Okay, we will continue to the next one. Okay, now we have a special case. This one is a special case for acceleration which is called the constant acceleration. يعني عندي تسارع ثابت، خلاص مشغل مثبت السرعة وناسي السيارة. Constant. So it says here constant acceleration means that the velocity is changing by equal amount in equal time intervals. You can see over here. Let me show you. Okay, this guy. This graph over here. راح تشوفوا ان الخط حق الفيلوسيتي كذا صاعد بصعود ثابت. ليه؟ لان الاكسلريشن حقه يكون ثابت. Is this one. It's not zero but it's constant at something. يعني ثابت عند رقم معين. خلاص انا اتسارع مثلا 5 متر في 5 متر per second square. فدائما تكون سرعتي في ازدياد وما راح تكون شو اسمه البوزيشن فيكتور حقي البوزيشن جراف حقي راح يكون كذا. my position is changing over time. It's going like this. المهم you just understand that you will have a constant increase in velocity when you have a constant acceleration. Okay, when we talk about this case which is the special case of constant acceleration, عندنا شيء اسمه equations of motions. we have 3 basic equations or 2 basic equations, then we can derive the other equations from them. اللي بيكم تعرفوه يعني just understand and try to you don't need to you don't need to know the derivations, you should know the final equations. الايكويشن الأول v equal v initial plus at السرعة النهائية this one تساوي السرعة الابتدائية v initial زائد التسارع في الزمن v equal v initial plus at. هي جاية من هذه but you don't need to know it. يقول لك هنا this equation reduces to v equal v initial إذا عندي صفر، يعني التايم زيرو at time zero بعدني ما تحركت سرعة الابتدائية نفس السرعة النهائية. Okay, you should just know this, the first one, v equal v initial plus at. If you want to do some calculations and manipulations, stuff like that, you will get the second one, which is x minus x0. يعني البوزيشن النهائي حقي هنا كنا يقول لك x final minus x0 يعني x final minus x initial كلها نفس الشيء. It's equal to v initial t plus half at squared. Another one you should memorize, just keep it in your head. And yeah, basically whenever you do some mathematical manipulations, you can get more equations out of them. I want to go to the table. Yeah, this table. I believe this is the most important table in this chapter. It's really good. I always advise the students that come to memorize this as it is. أبغاكم تحفظوا ذي الجهة هذه equation وذي الجهة missing quantity. ليه؟ لأن يجيك سؤال مثلا وراح تكتب والله اعطاني acceleration واعطاني وقت واعطاني v initial واعطاني مثلا المسافه اللي قطعوها، فمن تعرف اشياء وتعرف ايش المفقود عندك تروح لهذا الجدول تشوف اوكي والله انا مثلا مفقود عندي هنا الفي نهائي، خلاص اقدر استعمل هذا القانون بس. that's it بدون ما تعور راسك. you just look at the question, find what is given, find what is missing, go to the table and use the equation that relates to the missing quantity. That's it. خلاص عندي missing x minus x0 بستعمل أول قانون، عندي missing التايم راح استعمل القانون الثالث، عندي missing مدري ايش بستعمل قانون that corresponds to it. يعني you should memorize this. Honestly, this is one of the things that you should memorize. احفظهم كذا بالترتيب، احفظ المعادلات ذي واحفظ الميسنج ولا خلها عندك على جنب في نوت ولا اي شيء just to go back to it whenever you feel like you don't know how to solve the question. Okay. This checkpoint is pretty easy. He's saying the following equation give the position x of t of a particle in 4 situations. قبل شوي مر علينا checkpoint في نفس الشيء في equation حق x of t، بس هنا شويه سؤال مختلف. اعطاك 4 حالات 1 2 3 4، قال لك to which of these situations do the equations of table 2.1 apply. تونا قلنا ان عندنا الحين special case لما يكون عندنا الاكسلريشن constant، فالحين راح نطبق نفس اللي طبقناه في التشيك بوينت اللي راح نسوي اشتقاق ونطلع الاكسلريشن حقنا ونشوف متى الاكسلريشن يكون ثابت عشان نقدر نطبق القوانين. ف if you want to take a paper or anything next to you, you can try and do the situations. يعني try to do one by one. Let's try to do situation 1 where it says x is equal to 3t minus 4. فإذا بجيب الفيلوسيتي كلكم تعرفوا أن لازم نسوي اشتقاق، والاشتقاق حق ذي مرة سهل، راح يكون 3 التي راح تطير والسالب 4 راح تطير. الحين جبت الفيلوسيتي، كيف اجيب الاكسلريشن؟ راح اعطيها درب مره ثانيه، فيطلع لي الاي ايكوال بما ان الثلاثه هي رقم فالاكسلريشن راح يطلع لي 0. اذا الاكسلريشن هنا كونستانت. فاول معادله نقدر نطبق عليها القوانين حق الايكويشنز اوف موشن. زين. let's look at the second one. The second one is saying x is equal to minus 5t cubed plus 4t squared plus 6. Now if I take the first derivative I will give you the velocity. راح يطلع لك سالب 15 t تربيع plus 8t plus 6. Now we need to get the second derivative to get the acceleration. This will be minus 30t plus 8. Now مثل اللي صار في التشيك بوينت اللي راح، إذا عندي variable مع الرقم، إذا هذا الشيء مو constant. ليه؟ لأن هذا الاكسلريشن أقدر أقول لك والله في الزمن 5 ثواني عندي acceleration معين، وزمن 20 ثانية عندي acceleration معين. ليه؟ لأن بحط الزمن في التي وراح يطلع لي شيء مختلف بالضبط، ممكن يتغير. So the basic idea over here is that you just get the derivative. You will see if you have a variable، واللي نقصد به طبعا هو time variable، ما عندنا شيء ثاني غيره، وتشوف هل هو موجود ولا لا. If it's there يعني مو constant. If it's not يعني أمور نفس سليم. خلينا نجرب رقم 3. x is equal to 2 over t cubed minus 4 over t. هنا أبيكم تحولوها للشيء الطبيعي اللي تونا تكلمنا عنها عشان تكون أسهل. يعني 2 over t cubed تقدر تكتبها 2t minus 3، والسالب 4 على t تقدر تكتبها minus 4t to minus 1. No. أول شيء اكتبها بشكل طبيعي وبعدين نسوي. أنا كل اللي سويته إني شلت t cubed من تحت المقام ورفعتها فوق. Okay guys, I transformed the t cubed to t minus 3. شلتها من المقام حطيتها في البسط. اوكي خلاص، والحين اجيب الديريفاتيف مره ثانيه. v هنا راح تطلع لي سالب 6 t minus 4 then plus 4 t minus 2 and then واضحه انها ما راح تصير، لان في هذه النقطه وعندنا t زياده. اجل اذا رحنا للاكسلريشن so yeah it's gonna be a huge mess. 24 t minus 5 minus 8 t minus 3 and then you will change this to the normal notation. إذا عندك t to the minus 5 يعني راح ينزل تحت ب t أس 5. So yeah, just I want to show you the basic idea, and since we have t then it is changing. خلينا نشوف let's look at the last equation just to make our life correct now. x equal 5t squared minus 3. راح اجيب اول مشتقة عشان اطلع velocity، راح تطلع لي 10t، والمشتقة الثانية acceleration it will be 10. So it is constant, so we can use our table on this. Okay, excuse me for the time. Wallahi, I'm taking so much time. Okay, let's move on. This slide is talking about free fall acceleration. There should be a picture over here, but it's not showing. Okay, this is it. بشكل عام إذا عندك بيئة vacuum يعني ما فيها هواء، ما فيها شيء، ما فيها أي شيء يأثر على الفريكشن ولا أي حاجة، سواء حذفت تفاحة ولا حذفت ريشة من فوق، اثنينهم راح يطيحوا بنفس التسارع وراح يوصلوا للأرض في نفس المدة. Why? Because they are falling under the free fall acceleration, which is the acceleration due to gravity. Here, this one, I don't know if you want to mind it, but في السؤال راح نكتب A وراح نقول هذا free fall acceleration، لكن راح نستعمل minus G. So just forget about it right now. الماينس بس حق الدايركشن. So just understand that the free fall will follow this acceleration. Free fall acceleration varies with latitude and elevation, independence of properties. ما له علاقة بالmass, density, shape or anything. خلاص أي حاجة تطيح راح تطيح بالجاذبية الأرضية. And also, since the gravitational acceleration is constant and not changing, then we can use the table that we were talking about so just a few slides ago. Okay, this is the explanation. The free fall acceleration is downward. احنا نطيح باتجاه يعني, so it's the negative y direction. So the value minus g and the constant acceleration equation. This is again just a nonsense about the sign itself. This one is also this checkpoint. I don't really like to talk about it because it makes some confusion about the fall itself. Let's try. Let me see. So it says if you toss a ball straight up, حدفت كرة فوق. What is the sign of the ball displacement for the ascent? يعني الارتفاع، يعني قاعد اطلع فوق. هذه كلمة ascent معناتها طلوع الى الاعلى. فيقول لك انت الحين حذفت الكرة الى الاعلى. ايش الاشاره حق الديسبيسمنت؟ الاشاره موجبه راح تكون، لان قاعد ارتفع للاعلى. الكره قاعد تقطع مسافه، يعني مثلا كانت في ارتفاع 1 متر ووصلت ل 5 متر ووصلت ل 10 متر. سو الديسبيسمنت حق الازاحه موجبه. اوكي. now from the release point to the highest point هو اوكي هذه just تكمله السؤال. B what is it for the descent؟ الحين الكره قاعد تنزل، الكره descent it's coming from the highest point back to the release point. اذا عندي الكره راح تنزل من فوق لتحت، ايش راح يصير في الديسبيسمنت حقي؟ سو راح يكون negative because you're going from يعني displacement اذا تتذكر هو x2 minus x1. فاذا عندي الارتفاع النهائي 10 وهي نزلت ليدي 1 متر، فمثلا مو 1 مترين مثلا، فراح اجيب الديسبيسمنت فبقول له مثلا 2 minus 10 فيطلع لي بالسالب. so it's really nonsense. وهنا يقول لك what is the ball's acceleration at the highest point؟ قاعد نتكلم احنا عن free fall، فبما ان نتكلم عن free fall يعني تسارع للجاذبيه الارضيه فهو 9.8 والدايركشن حقه بالسالب على تحت. yes we should use minus 9.8. well not in all equations, we will see. I believe yes. لكن اذا عندي free fall، اذا قال لك هذا free fall والاوبجكت is under the gravitational acceleration, it will have the negative sign. We'll see, my friend. Okay, now we're coming to the summary. Instantaneous velocity, it's the derivative. I think there's one missing over here. Yeah, the average velocity. The average velocity is delta x by delta t. Instantaneous acceleration, a is equal to dv by dt. Average acceleration, a average is equal to delta v by delta t. And including free fall, we should use a equal minus g. I think you are right. I think we use minus 9.8 in all equations. I don't really remember. We will see in the questions. On this table, this legendary table, you should all memorize it, or at least keep it to your side or anything like that. We talked about this positive increase, negative increase, positive negative positive decrease. So يعني if you have similar signs, it's increasing. Different signs, it's decreasing. Okay, good. We reached the problems. Let me just prepare it really quickly. Don't be scared if the problem is too big. Whenever you see a problem that is very big, يعني all the things inside are very easy to do and straightforward. So please tell me you can see the problem right now. Okay, good. Okay, let's try to finish this in, I don't know, 10, 15 minutes, and then we will left with one chapter. Okay, so this question, it's a long one, but it's really straightforward. Yani there is nothing to it. So it says the position of an object moving along an x-axis is given by this equation. أعطانا هذه equation. X is equal to 3t minus 4t squared plus t cubed. where x is in meters and t in seconds. Find the position of the object at the following values. يبي يعرف البوزيشن في هذه الأوقات. يعني أعطاك أوقات 1 second 2 second 3 seconds and 4 seconds. فإيش راح نسوي؟ حنا عندنا الإكويجن مال البوزيشن أوريدي ونبيها بس في هذه الأوقات. ف راح تطبق تطبيق مباشر، تحط الوقت في هذه المعادلة عشان تشوف هو في أي بوزيشن. فأنا بسوي واحدة بس وخلاص. You should all know that it is in similar manner. عند الثانية at time equal to 1 second you should لا ما تشتق هنا. السؤال يقول find the position of the object وانت اصلا عندك the equation of position. لسه ما قال ابي velocity ولا ابي acceleration. اوكي اوكي طيب خلاص. حطينا الوقت في المعادله. انا عندي معادله بوزيشن فيها تايم وقال لي السؤال في هذا الزمن وين كنت. خلاص احط الزمن في المعادله. 3 ناقص 4 زائد 1 كم يساوي؟ 0. خلاص اذا at t equal to 1 انا كنت في بوزيشن 0. اوكي خلني نجرب بعد واحده ثانيه عشان this is at t equal to 1 second. Let me show you another one at t equal to 2 seconds. فراح اجيب الاثنين واعوض بها في المعادله اللي عندي اياها. حلو خلاص. and then just use your calculator to see what's your position at t equal to 2 seconds. Okay, so it is -2. So it's straightforward. Just plug in the times that are given to you in the equation. لأنه ما قال أبي velocity أو أبي acceleration. ما قال أي شيء. Since he did not mention any of those things, you don't get the derivative or don't do anything. So this is for part A, B, C, and D. تطبيق مباشر. A, B, C, D. What about the unit? Position. You tell me the unit. What is the unit of position? Thank you. And meter. Okay, good. Now, part E. Part E. What is the object's displacement between t equal to 0 and t equal 4 seconds? Now you will let me solve it. We're talking about the displacement. Okay, we all know that the displacement delta x is equal to x2 minus x1. يعني the final position minus the initial position. Here it's asking t equal 0 and t equal 4. للأسف حنا حلينا t equal 1 and we did not solve anything else. اوكي بنسويها. في التايم 0 إذا حطيتها ايش البوزيشن حقي؟ كله أصفار. اوكي التايم equal to 4 خلينا نكتبها. Yes, let's write it down. So let's use here 3 times 4 minus 4 into 4 squared plus 4 cubed. هذه حق الأربع ثواني حق الفاينل بوزيشن. and then minus 0 لأن t equals 0 كلهم بيصيروا 0. اوكي ما شاء الله. You all got the answer. Okay, good. 12 خلاص أصدقكم. 12 minus 0 it will be 12. The answer will be 12 meters. Then again, part E was only asking about the displacement. Here it is. What is the object's displacement between t equals 0 and t equal 4 seconds? فللزيرو طلع لنا 0، لل4 seconds طلع 12. خلاص راح يصير 12 ناقص 0 يساوي 12. Okay. Let's look at part F. F is saying what is the average velocity for the time interval from t equal 2 seconds to t equal to 4 seconds. الحين نحتاج velocity. الحين نحتاج velocity. V average is equal to ليه رايح فوق؟ Okay. V average is equal to delta x by delta t. From where? From time interval t equal 2 seconds to t equal to 4 seconds. خلاص. إذا نحتاج already عندنا الوقت 4 minus 2 والحين نبي البوزيشن. نعرف البوزيشن حق الفور اللي هو 12. باقي نعرف البوزيشن at 2 seconds. ما أتوقع حليناها صح؟ Okay, we can find it. If you put 2, no, we did. Oh, sorry, we did. It's minus 2. خلاص. We put it here, minus 2. Yes. That's it. خلاص تطبيق مباشر. You'll find it 14 over 2, and this will equal to 7. Yeah. What is the unit? Yep. Good job. Now, part G is saying, graph x versus t for 0 to 4 seconds and indicate how the answer for f can be found on the graph. Before we graph, I told you before أن ال V average تكلمت عنها is the slope of x versus t. عشان كذا نروح نجيب لنا جراف محترم يكون فيه x versus t. So if we graph x versus t, and then we look at the points where they indicate our 2 seconds and our 4 seconds, okay, and then we draw a line, the slope of that line will give us the average. Okay, guys? All good? I don't think you will get any drawing in any quiz, especially right now since it's online. Okay. Let me just go to the next one. Okay. This one is saying the displacement of a particle moving along an x-axis is given by x equal to 18t plus 5t squared. أعطاك الديسبليسمنت وهذا الإيكويشن حقه. Where x is in meters and t is in seconds, calculate the instantaneous velocity. الحين بما أنه سأل عن velocity, instantaneous velocity, we all know that v is equal to dx by dt. إذا هنا لازم أشتق. At t equal to 2 seconds. يعني بعد ما أشتق أحط. So okay, let's start. So dx by dt 18t هنا هذه واضحة راح تصير 18 وهذه راح تصير 10t. I think I should write this here so that no one can forget this. If I have a x to the power b, then المشتقة راح تصير ab x to the power b minus 1. مشتقة. This is the basic idea. Okay. Now, since we get this, you can write dx by dt. You can write it as v. خلاص, you should know by now that v is equal to 18 plus 10t. And now at t equal to 2 seconds, you just put the number. So v at 2 will equal to 18 plus 10 times 2. I believe someone got the answer. Yes, 38 meter per second, which is velocity. Now, B is saying the average velocity between t equal to 2 seconds and t equal to 3 seconds. Wait. This was part A. Now part B. We want the average. Now V average is delta x by delta t. And since he gave us 2 and 3, so we all know this. Now, how do I get delta x? I should plug in the numbers in the equation as it is. So at t equal to 3 seconds, my x should be, my x should be 18 times 3 plus 5 into 3 squared. And this will give me a position. And at t equal to 2 seconds, my x should be the same thing, but change the 3 to 2. Did you get it? Yes, 99 and 56. 99, 56 meter. Okay, so you just plug in those numbers over here. Thank you, by the way, for following with me. Yes. And then now you will get the V average. Mom, thank you for that. 43 meters per second. Okay, that's basically the question. Let me just save it and we'll go to the next one. Okay, now we will have 3 questions that are related to constant acceleration. So yeah, even though if you solved it before, but في الإعادة إفادة. By the way, I didn't ask. Did everyone understand this? Anyone has any question? If you do, please stop me. Please talk. No? Okay. Okay, good. Okay, so this question, let's read it together. It says, along a straight road, a car is moving with a speed of 130 kilometers per hour and is brought to a stop in a distance of 210. Okay, so أعطاك speed v is equal to 130. Brought to a stop in a distance, so يعني x minus x0 is 210. And then يقول لك find the magnitude of the deceleration of the car assumed uniform. Since he said uniform, then it's constant. And then he's saying how long does it take for the car to stop. Okay, so ناخذها حبة حبة. So it's saying a car is moving with a speed of 130, is brought to a stop. Brought to a stop, it means that this was our V initial and our V final will be 0. I don't think so, man. Mr. Yasser, you should memorize those. Yeah. Okay. You have the speed of 130 brought to a stop in a distance of 210. Find the magnitude of the deceleration of the car. So we want to find A, which is assumed to be uniform. And also, how long does it take for the car to stop? Okay. So which one should we use? Four. Yeah. Why? Because our acceleration is missing. And if we plug in our numbers and our values, we will find, you will get the time, and then you can play around again and find your acceleration. So yeah, you are correct. We can use equation number 4. So equation number 4 is saying x minus x0 should equal to 1/2 v initial plus v times the time. So we're looking for the time over here. So just a simple mathematical manipulation will give you 2 times x minus x0 over v initial plus v. I hope I'm right. Now just multiply 2 over here. Okay, yeah, I think we're good. Yeah, and now just plug in your numbers. So 2 into 110, and then 130 plus 0, and you will get your time. So 2 times 210 over 130. So your time is in 3.231 seconds. So we got the time, and now you can go back to the original equation, which is v is equal to v initial plus at, and you can find a over here. So a is equal to v minus v0 over t. So minus 1t divided by 3.231, and you will get the value of your deceleration. No, you don't. يعني well, يعني to be clear, kilometers per hour. Oh, yeah, I think you should. But really, it's not going to make any difference. It's the same numbers. It's the same numbers, nevertheless. But since you have the time and you want to change the unit, I believe you should. So you should change them. Yeah, my bad. You should change kilometers per hour to meters per second. God. Okay, if it's a multiple choice, then yes, you should do it. Which question is this? Yeah, it's 21. اوكي. ليش ال 130 صارت سالب؟ لان القانون هذا اللي هو v equal v0 plus at حولت في الاحرف عشان ابي اطلع الاكسلريشن على جنب، فجبت ال v0 من ذي الجهه وقسمت على t. فلما نحول ال 130 كيلومتر per hour, it will be just like our friend just said, 36 or 38? Yeah, 36. 36.12 meter per second. Yeah, okay, sorry about that. You should we should pay attention to this. I believe then my time would be wrong over here. Okay, 2 times 210 divided by 36.12. Yeah, you're correct. 11.663. Okay, it doesn't matter. It's the same. Wallahi, as long as you're understanding the basic idea, it's good. Okay, so two people asked two things. The one who said why it's negative, and the question. Okay, so it's question 21. We're good. ليش صارت سالب؟ لأن شوف عندي هذا القانون هنا الأساسي اللي هو equal v0 plus at، وأنا أبي أجيب التسارع. فكل اللي سويته إنه نقلت ال v للجهة الثانية، فصارت v minus v0 equal at. خلاص ظلت التسارع مع الزمن، فبقسم تطلع لي كذا القانون. فأنا عندي اوريدي السرعة النهائية 0، وهذه سرعتنا الانيشال صارت بالسالب. وهو أصلا قال لك the car is moving with a speed ما أدري إيش and brought to a stop. بعدين قال لك find the magnitude of the deceleration. الديسلريشن معناتها بالسالب، acceleration معناتها بالموجب. But he asked about the magnitude also. Yeah, we're just finding it. قسم 36.12 divided by 11.63. Here you go. No. Find the magnitude of the deceleration. Oh, you're yes, you're correct. you should calculate it like this, يعني do everything, and then when he is asking about the magnitude, just give him the number without the sign. Are you sure it's all multiple choice? Okay, then if it's multiple choice, then and he's asking about the magnitude, then never mind the sign itself. Well, yes, it could be tricky. If he says deceleration, then you should always be considerate of this one. Okay, please tell me you all understand this one. Okay. One second. Okay. So this is question 35. It's saying in a particle accelerator. هذا في العادة يكون جهاز يستعملوه في المختبرات ويحطوا فيه نواة ويحطوا فيه أشياء ويخلوها تتسارع بسرعة عجيبة. It says in a particle accelerator an electron enters a region in which it accelerates uniformly. يعني عندنا acceleration constant uniform يعني نقدر نستعمل هذا التيبل حقنا. In a straight line from a speed of يعني أعطاك ال V initial equal 4 times 10 to the 5 meter per second to a speed of V final 6 times 10 to the 7 meter per second. وأعطاك ال distance يعني x minus x0 3 centimeters. السنتيمتر هذه لازم نحولها لمتر. So 3 divided by 100 it should be 0.03 meters. And now he's saying for time interval does the electron accelerate? What's our time? How can we do this? يبي التايم وعندنا الاكسلريشن missing. فايش راح نستخدم؟ I believe we will do the same thing. Yeah, we're using the same equation just like we did a minute ago. خلاص. Okay, then I can make some shortcuts over here. We can say that t will equal to 2 into x minus x0 over v0 plus v. But plus. For what time interval does the electron accelerate? We don't even need to find the acceleration. خلاص just تطبيق مباشر. God. Okay, that's really fast. 9.93 times 10 to the minus 10 seconds. Okay. So this is it. This is the question. So as long as you know how to use this table, your life would be easy. So the question is asking for what time interval does the electron accelerate. يعني هو السؤال أصلا يبغي له وقت واليونت المفقود عندك اللي ما عندك إياه ما عندك acceleration. خلاص تروح للميسنج كوانتيتي اللي هي الاكسلريشن هنا. خلاص راح تستعمل القانون وراح يطلع لك الفاريبل اللي تبيه. Let me just everything is good. everything is clear. It is the same as question. Yeah. Yes. كله clear. Okay, one more question and then we're taking a break and then we will come back to our final chapter, which is about vectors. Should be easy, but we will take a good break so that you can stretch and maybe, yes, we can go to pray as well. We missed the prayers. Okay, just bear with me for a few minutes. كله clear بس كثيرنا قاعدين ناخذ كل اللي أخذناه. Yeah, well we have to يعني in case someone forgot anything or he needs some help. It's fine. Okay, this is interesting. الاختبار تأجل ولا لا؟ الاختبار تأجل. Okay. So be more easier practicing. So always will be this long. Okay. خلاص في ناس ما تأجل لهم. بالنسبة اللي يسأل so always will be this long. لا. بما احنا المفروض نبدأ الهيلب سيشن من الويك 3 بس الإدارة كانت مرة مزحومة اللي هي إدارة البلاك بورد وما أعطتنا الأكسس على البلاك بورد نفسه إلا متأخر. I had to start whenever I had the access and I have to finish or cover whatever you guys went through. فبالنسبة اللي ما تأجل لهم you can stay. And by the way I told you guys هذا أول كلاس مو محسوب لكم الحضور, so if you want to leave you can leave. For the people who have the quiz tomorrow you can stay. Normally my help sessions don't take more than an hour. يعني an hour is too much لأن راح أكون أمشي مع الدكتور وأحل الأسئلة وأشرح الدرس في وقت يعني good. يعني أنتوا لو تلاحظوا الحين we almost took an hour and something for each one. This is only just for the beginning. Later on it will be more in control. So okay, let's just finish this one and then move on. This is question 60 from your book. Okay. This one is a little bit it's not tricky, but if you understand it then it should be really good. So it says a rock is thrown vertically upward from the ground level. عندنا ground level وعندنا حجر راح نحدفه up a tall tower. A rock is thrown vertically upward from a ground level at time equal t equal to 0. يعني at time equal to 0 أنا عندي الروك في ground level. At time equal t 0.15 seconds it passes the top tall tower t 1.5 seconds. عدى من هنا خلاص إذا الروك حذفناه وعدى ال tall tower. And 1 second later it reaches its maximum height. عندي هنا maximum height وين بعد الثانية يعني at t equal to 2.5 seconds لأني بضيف ثانية على the top of the tower. It reaches its maximum height with the height of the tower. إذن basically قاعد نسأل عن ال x minus x initial حق التاور نفسه. يعني أقدر أقول مثلا أن التاور أسميه h1 وأقدر أعطي ذي المسافة هنا مثلا أسميه h2. فيطلع لي إن ال h1 اللي هي height of the tower is basically sorry for that. ال h1 is equal to x minus x initial. فنحاول الحين نجيب لنا Can you all still hear me? Did I disconnect? Okay, you can still. Okay, good. Okay. احنا حدفنا حجر thrown vertically upward يعني احنا قاعد نتكلم عن حالة الفري فول. ففي حالة الفري فول عندنا دائما A is equal to minus G so it's equal to minus 9.81 أو 9.8 يعني to be clear. وش بعد نقدر نقول بما أن الحجر وصل للنهاية ف at the very end our V final was 0. إذا من هذه المعلومات أقدر أستعمل هذا القانون الأساسي اللي هو V equal to V initial plus AT عشان أجيب السرعة الابتدائية، لأن عندي السرعة النهائية وعندي الأكسلريشن وعندي الوقت، أقدر أجيب السرعة الابتدائية. ف just basic mathematical manipulation over here. So V0 will equal to V minus AT. We'll plug in my number, so my final velocity is 0. This minus will go in just like it is. A بعوض بها minus 9.8 والزمن عندي للنهاية للماكسيمم height is 2.5 seconds. Okay, so if my calculations are correct, my V initial will be, yes sir, 24.5 meters per second. خلاص إذا أنا استفدت من الحالة أنه وصل فوق على أنه when he says maximum height خلاص يعني there is no more to go. الفيلوسيتي حقي خلاص وقف. That's it. Now نبدي نطبق الشيء اللي عندنا. عندنا V initial وعندنا V final وعندنا acceleration وعندنا زمان. إذا المفقود هو ال x minus x final. ما نحتاج نستعمل التيبل، نحتاج بس أي equation فيها x minus x initial. نستعمل أي واحدة ما يضر، فنقول له مثلا نستعمل اللي هو ثاني واحدة. Oh no, I'm sorry. Let me make this clear again. Now we want to find the height of the tower here. So we have V initial, we have the time, we have the acceleration. We want x minus x final, but we don't have the final velocity. هنا ما نعرف كم السرعة. So yeah, since our missing quantity is V, so here we use the second equation. Yeah, this is the thing that is important in this question. We're missing a quantity is the final velocity when it's reaching the top of the tower. Okay, I will just use the second equation, 1/2 AT squared, and just plug in the numbers that we have. So 24.5 multiplied by the time, 1.5 plus 1/2 multiplied by 9 minus 9.8, and then the time again squared. خلاص, just plug this number in your calculator and you'll see. Okay, man, 25.72. And what is your unit? Yes, and meter. خلاص, this is a question. I hope everyone is clear with that, and if not, you can tell me. You can ask me at any time. We finished this chapter and we finished those questions. For the people who have their if they have their quiz, اللي تأجل كويزهم يعني إذا تبوا تطلعوا it's up to you. اللي كويزهم بعده بكرة راح أتكلم عن chapter الفيكتورز just after a small break. And don't worry, the session is recorded and everything. So yeah, let's have a break of 10 minutes, please. Some around 10 minutes يعني. If you can come at 9:40, it will be really good. Yeah, thank you for attending. اللي يتأجل لهم تقدروا تقدروا تناظروا التسجيل الموجود، واحتمال يعني احتمال اسوي another help session at the weekend. في العاده اذا اسوي help session في الويكند يكون بدون حضور، الحضور الالزامي يكون اللي في منتصف الاسبوع. اذا بسوي في الويكند ويكون مره قصير يعني، وبس اللي عنده استفسار او شيء. I will let you know of everything in the WhatsApp group. Yes, you can ask your question. أنا الأدمن. متأكد حطيت رقمك صح في الفورم. Can you type in your ID please? 418. One second. ممكن أعطيتني رقم مو حق واتس. One second. 7233 056 634. Are you sure you're not with me? 7233. See, that's your problem, man. ايه برفع السلايد بس اخلص من الشرح ان شاء الله. The slides that I شو اسمه شرحت عليهم. ايه ما في مشكلة، تقدر تغير. عطني ارسل في البرايفت شات your new number. Okay, let me type that in. الله يعافيك. Okay, it's 9:40 right now, and I should start so that I don't take too much of your time right now. It's been 2 hours and 40 minutes, and so we'll see what will happen. Okay, for the ones who are still over here, are you for your quiz tomorrow or? Okay, okay. Oh, next week. Wow, والله صامل ما شاء الله. حتى انت have it week 5 ما شاء الله. Okay, up to you guys. Yeah. Okay, so vectors. بشكل عام the chapter يعني should be straightforward, but I don't know how long will it take. Hopefully not too long. Okay, good to know. Thank you for sharing this. Okay, so vectors. Let's go over it one by one and we'll see what we will find over here. Okay, so vectors and their components. Basically, we're talking about vectors and scalars now. A vector quantity, you all know that it has a magnitude and a direction. We all know that the things we just took, position, displacement, velocity, average velocity, acceleration, stuff like that, weight, all of those are vector quantity. Scalar quantity, speed. ما حط له speed. Speed is a scalar quantity. It has only a magnitude, does not have a direction. For example, mass, time, temperature, pressure, and energy. Now, here is the important part. A vector is represented by an arrow whose length is its magnitude and its head is the direction. So, like this. If you don't know what an arrow is, this is an arrow. The symbol is a letter with a small arrow on it. So let's say that this is velocity and this is the velocity vector. This is acceleration, this is the acceleration vector. So it's length over here. If you're using vector multiplication or addition and you're using it using drawing, the drawing itself should be very precise. يعني هذه المسافة راح تمثل الفيكتور نفسه. You will see that you will see this will make a huge difference when if you're a civil, mechanical, or I believe also for interior design. And when you're using vectors and stuff like that on a drawing sheet, a vector, the vector length will comprehend its magnitude, and the vector head will comprehend its direction. Okay. Yeah, you can see this. So arrows are used to represent the vectors. The length of the arrow signifies magnitude. The head of the arrow signifies direction. So you can see those different arrows and stuff like that. Sometimes the vectors are represented by bold lettering. We're not considering that right now because we're not drawing anything. The next slide, if it can come. Okay. Yeah, okay. So starting with adding vectors graphically. You can add vectors graphically. So vector sum, basically, if you have this vector over here and then you have a vector over there and you want to add them, so الذيل حق الفيكتور الثاني لازم يكون في الراس حق الفيكتور الأول. So it will say it over here. Consider a particle undergoes two displacements as shown من A إلى B ومن B إلى C. Then the vector from A to C represents the resultant هذا الطويل. The resultant displacement vector sum of the two displacement. So here it says to add A and B, draw them head to tail. يعني لازم يكون just like I said a minute ago. الذيل حق B لازم يكون في راس A. And then you can add by getting the result. And this is the resultant vector from the tail of A to the head of B. خلاص resultant يكون this guy over here. Now it can be added graphically or it can be added algebraically. So this is the net. It's basically A plus B. Okay, adding vectors geometrically. Vectors A and B can be added geometrically to the resultant. Same thing. You can add them by the geometry. Place the second vector B with its tail touching its head, and then you can measure this distance. Again, we're not doing because we don't have any drawings. Vector addition is commutative. يعني إذا قلت A plus B is the same as saying B plus A, you can change the order, and you can see this over here in the drawing. كان عندك ال A رايح فوق وبعدين ال B نازل تحت، وإذا قلبت قلت له أوكي بنزل تحت أول شيء بعدين بروح فوق. It's the same thing. The resultant is the same. You will get the same vector result for either order of adding vectors في الaddition. Also vector addition is associative، يعني إذا قلت A plus B داخل قوسين وبرا plus C, you can take any one of them out and then you can group them as much as you like. again تقدر تشوفها في graphically you can prove it for your own يعني. Okay, for subtraction, how do you subtract? It's basically a negative sign reverses the vector direction. So if you're saying B plus negative B يعني بس راح تقلب الاتجاه حقه. And so we use this definition to define vector subtraction. يعني إذا قال لك مثلا عندي A minus B فهي نفس الشيء as saying A plus the negative of B. بأجمع لكن راح أقلب الثاني. And we can see this also graphically. If you have A and B, so this is A over here, you can see this is A, and this is the normal B. See, it's going out. Now, if you want to subtract, راح تقلب، راح تجيب السالب B, and then you will do the same operation. راح تجيب الذيل حق B وتحطه في راس A وبعدين تاخذ this resultant over here. So he just wants you to know that subtraction is basically addition and the negative of the second one. Okay. Moving forward, these rules hold for all vectors, whether they are represent displacement, velocity, and whatnot. So a vector is a vector no matter where it is. Again, here it's a very common sense thing. It says only vectors of the same kind can be added. يعني بس تقدر تجمع displacement مع displacement أو velocity مع velocity أو acceleration مع acceleration. ما تقدر تقول له والله أنا عندي vector displacement أبي أجمعه مع vector velocity. ما راح يصير. It should be at the same kind. هنا عندنا checkpoint. It says the magnitude of displacement A and B are 3 and 4 meters. عندك ال A 3 وهذا 4 respectively, and C equal A plus B. Consider various orientations of A and B. What is the maximum possible magnitude for C and the minimum possible magnitude? سؤال مرة straight forward، بس يقول لك ايش الماكسيموم اقدر احصله من الاورينتيشن حقهم وايش المينيموم. الماكسيموم واضحة، راح اجمعهم اثنينهم 3 plus 4 is equal to 7. والمينيموم هو انك تطرح، بس تطرح ايش؟ تطرح الكبير، تشيل الصغير من الكبير. So 4m minus 3, which is 1. I don't know if this is a checkpoint or this is just to waste our time. Components of vectors. طبعا if you have a vector that is drawn anywhere, you will have a component. So here it says, rather than using a graphical method, vectors can be added by components. A component is the projection of a vector on an axis. Okay? The process of finding a component is called resolving the vector. يعني أنت راح تحلل الفيكتور إلى البروجكشن حقه. Here it says the component of a vector can be positive or negative. They are unchanged if the vector is shifted of any direction. يعني ما لها علاقة إذا غيرت الفيكتور. We will see it in the next. What is this? The component of a vector can be positive or negative. We just said that. Okay, this is just a repetition. Okay, this is the real deal. Components in 2 dimensions can be found by this AX and AY. إذا عندي فيكتور محطوط في مكان أقدر أجيب ال X component وال Y component. فهنا استخدمنا مثلا acceleration، فأبي أجيب ال X component حق ال acceleration، فبقول له A cosine theta. Always like this. ال X component حق ال acceleration A cosine theta، وال Y component حق ال acceleration مثلا A sine theta. Okay. Now it's always like this when this condition applies, where theta is the angle the vector makes with the positive x-axis. يعني هذا ال x-axis اللي هنا، هذا ال y، والvector حقك let's say it's here. So if this is your angle, then you can always say that your x component will be with the cosine and your y component will be sine. Now, what if it's different? What if I'm talking about this angle over here? Simply راح تقلب، راح تقول ان الاكس component حقي راح يصير الساين والواي component حقي راح يصير كوساين. Basically what I'm saying الكوساين راح ياخذ الزاوية المجاورة، يعني أقرب زاوية لك. فبما أن الزاوية هنا القريبة للإكس، خلاص راح يصير الإكس كومبوننت الكوساين. هنا الزاوية راح تكون القريبة للواي، إذا الواي كومبوننت هنا في ذي الحالة هو الكوساين. واضحة هذه؟ Is this clear? No. Okay. Okay. Let me open I think this one. Okay. هذا الفيكتور حقي بسميه V. الحين راح اجيب الكومبوننت، ابي اجيب الاكس كومبوننت والواي كومبوننت حق الفي. في هذه الحاله هنا في هذه الحاله بما ان الزاويه اللي عندي بين الاكس والفي، اذا الاكس كومبوننت راح ياخذ الكوساين والواي كومبوننت راح ياخذ الساين. هذه الحاله الطبيعيه اللي المفروض كل every other situation will go through this، هي ان تكون الزاويه حقتك this angle is in between the positive x direction and your vector. Okay, هذه مفهومة. This one, only this case. Is this case good? Okay. Now listen to me. راح أسوي نفس الرسمة. This is y, this is x. And then this is your vector v. لكن الحين راح أعطيك الزاوية هنا. حطيت الزاوية هنا. So what is different now? My angle is not with the x axis, it's with the y axis. عشان كذا إذا بكتب الكومبوننت الواي في هذه الحالة راح ياخذ الكوساين والإكس راح ياخذ الساين. ليه؟ لأن الزاوية الحين صارت هنا، صار موقع الزاوية بين الواي وبين الفيكتور. Okay? So whenever your angle is next to the axis تعطيه الكوساين. أي زاوية هي قريبة للأكسس راح تعطيها الكوساين، سواء كان قريب للإكس أو الواي. Just to make your life easier. خلاص احفظها like this. Okay. Okay, since it's good, let's go back to the slides. Just give me a minute here while it's loading. Okay, don't tell me I disconnected. Okay, you're good. Okay. So هو هذا definition it's written over here. It says where theta is the angle the vector makes with a positive x-axis and a is the vector length. إذا بما أن الزاوية in between the positive x-axis and the vector, we will do this unless it says otherwise. فتصير الحالة الثانية. Now this basic thing over here, the length and the angle can be found by those components. إذا تبي تجيب الماجنتيود راح تقول له x تربيع زائد y تربيع تحت الجذر, and the angle in between is basically tan theta of ay over ax. So yeah, the normal case is that our angle is always in the positive x direction. But just in case, يعني you might have an angle in the other direction, you will use it. Okay, so memorize this one, memorize that one. and you should good. Moving on. Okay, this checkpoint is interesting because it deals with the vector addition and stuff like that. Okay, it says in the figure, which of the indicated methods for combining the x component of vector A are proper to determine the vector. يبي يختبر بس هل انت فاهم الكونسبت of adding vectors، يعني اذا عندك vector كذا وvector كذا كيف راح تجمعهم، ايش راح تسوي. ف if you want we can zoom in on one by one and we'll see the cases together. So if you can see case A راح تشوفوا ان حق الاكس رايح كذا، حق الواي رايح كذا على تحت، وبعدين قال لك والله resultant is the guy in between them like this, which is wrong. هذه wrong الكيس. if we look at case B رايح يسار بعدين رايح تحت وبعدين قال لك resultant كذا, which is again it's wrong. if we look at C الاكس رايح يسار وبعدين الواي رايح منطلق منه ورايح نازل كذا, وبعدين resultant من بداية الأول لنهاية الثاني, which is the correct way to do it. This is the correct way of doing it. Yes, I got a message on WhatsApp. Yes, your answer, if you are here, it's yes. It's the same. طيب, part D تقدر تشوف ان بدأ أول شيء بالواي, الواي كان نازل تحت كذا, بعدين الإكس راح كذا, وأعطاك resultant من بداية الأول لنهاية الثاني. فنفس الشيء. This is correct. And then part E, it's opposite. صح إنه راح كذا بالإكس وبعدين نزل بالواي كذا, لكن أخذ resultant من نهاية الثاني, which is wrong. بالنسبة ل F, it is correct because حط لك هو هنا, حط لك ذول الخطوط المتقاطعة, and you can see if you put it over here and if you put it over there, it's the same thing. He's taking the resultant, which is the line in between them, which is also correct. So this guy is just showing you the different situations, different scenarios. You could get this in a multiple choice question with the pictures like this. So I hope it was clear for you. Was it good? Okay. أنت راح تبحث عن اللي ماشي ماشية صح, يعني إذا عندك اثنين تجمعهم لازم يكون بادي من بداية الأول وينتهي عند نهاية الثاني. تمام. أوكي. So third started from the first. أيوة, هذه فقرة C بدأ من الأول, بدأ من AX وانتهى عند AY. Okay, moving on. هنا راح يتكلم عن degrees and radians. So angles may be measured in degrees and radians. Recall that a full circle is 360 degrees or 2 pi if we're talking about radians. This is a conversion factor, you should know this. 360 degrees is equal to 2 pi, so you're either saying like this or like that. You should know that the basic trigonometric functions, we just talked about them, a sine or cosine or tan. If you can look at this triangle over here, if you have theta over here, this will be your hypotenuse, الوتر. This would be the opposite, المقابل, and this would be adjacent, المجاور. فالكوساين المجاور على الوتر, adjacent over hypotenuse. الساين المقابل على الوتر. opposite to hypotenuse. والtan هي المقابل على المجاور. In other words, this is normally x and this is normally y. عشان كذا نقول حنا cosine الزاوية مثلا cosine theta is basically x over r لأن الوتر يكون r والsine of theta is basically y over r والtan is y over x. So this is just to make your life easier. Moving on as well. This is for nonsense. Okay, now we're coming to something interesting. Unit vector will adding vectors by components. Okay. A unit vector is a unit vector. A unit vector is a vector of unit magnitude. يعني إذا جيب الماجنتيود حقه راح يطلع واحد. Pointing in a particular direction. Here it says a unit vector in any direction has a magnitude equal to 1, and we present it by this side. We use it for one purpose only, to point or specify direction as shown in the figure. فالunit vectors اللي عندنا هم ال I وال J وال K. I is in the direction of X, J is in the direction of Y, and your K is in the direction of positive Z direction. Okay, so basically whenever you have a vector, let's say vector A, it will have an X component in the I direction, it will have a Y component in the J direction, and it will have a Z component in the K direction if it's in 3D dimension. If it's in the 2D, it will have only I and J. So you should know what I and J means. Vectors can be added using the components. So you can add using the components. We simply combine their components. So in case if you have R equal A plus B, you can also say that Rx is Ax plus Bx, Ry is Ay plus By, Rz equal to Az plus Bz. Because sometimes you might have a question where you don't need to use all the components. You can use only, for example, the Y component. We will see in later chapters if we have let's say a ball thrown across a field or something like that. Your X component will make no difference, and you will have to use your Y component to calculate something else. So yeah, you don't have to use the whole thing. Okay. Continuing. Here it says unit vectors, adding vectors by components. The procedure for adding vectors also applies to vector subtraction. We just said that if you want to subtract, I mean, if you're adding components, you can also subtract components. So dx is ax minus bx, dy يعني راح تطرح بس بالcomponent. Let's see this checkpoint. This checkpoint is saying in this figure, what are the signs of the x components of d1? Oh, okay. So عندك هذا الفيكتور اللي هنا، هذا السهم. And he wants to know the signs of the component of d1. يعني d1 بما انه رايح فوق، إذا عنده component هنا. Let me do this again. It will have a component over here and a component over there. So the x component, the y component, both of them are positive. D2 is going down, so it will have a component like this and a component like that. So the x component is positive, the y is negative because it's going down. And then B is saying, what are the signs of the y components of D1 and D2? Oh, okay, we already solved that. Part C, what are the signs of the x and y component of the addition? Okay, إذا صار في جمع, if we added both of this, so you know that we should get the line like this. It is starting from the start of the first one and ending at the second one. فهذا الخط رايح كذا، فالcomponent حقه like this and like that. So both of them are in the positive direction. Again, I hope this is clear. This is only drawing and components. Is it good? Good. Okay, at least one is. Okay, أقدر أعيده. Yeah, ما في مشكلة. let me get you. السؤال انه طويل، بس السؤال يبي 3 حاجات. يبي اشاره الاكس كومبوننت، واشاره الواي كومبوننت، واشاره الاكس والواي حق الريزولتنت حقهم. فاذا تناظر هذا الفيكتور الاول، شوف ناظر هذا دي 1، شوفوا طالع فوق كذا، طالع فوق على اليمين، طالع يمين فوق. اذا بسوي له كومبوننت، اذا بوزعه على الاكس والواي، راح يتوزع كذا، راح يكون عندي هنا شوي وهنا شوي. حلو، كني بقول دي 1 كوساين ثيتا هنا، هنا كني بقول دي 1 ساين ثيتا. راح اخذ الكومبوننت بس. فالسؤال يسأل هل الكومبوننت موجب ولا سالب؟ وين رايح ذا الكومبوننت؟ رايح باتجاه الاكس موجب، فطلع موجب، وهذا صاعد للواي، اذا هذا موجب از ويل. اوكي، هذا بالنسبه لدي 1. حلو، اوكي. دي 2 ناظر السهم نازل يمين تحت. يعني اذا باخذ كومبوننت، اذا هذا السهم بجيبه وبجيب الاكس والواي حقه، تقدر تتخيل ان الاكس راح يكون في هذا الاتجاه والواي راح يكون في هذا الاتجاه. ليه؟ لان الريزولتنت حقهم نازل كذا على تحت. اوكي، سو الكومبوننت حقي هنا هذا موجب وهذا سالب. اوكي اوكي خلاص. now it's the last thing. الحين يبي d1 plus d2، يعني كاني بجيب الريزولتنت حقهم. الريزولتنت تونا متعلمين اذا نبي نجيبه لازم نبدا من الاول وننتهي مع ثاني. خلاص برسم كذا، يعني سوي لهم نفس الشيء. هذا طالع كانه طالع يمين فوق بعد، فاقدر اتخيل انه عنده كومبوننت هنا وعنده كومبوننت هنا. both of them are positive. اوكي تمام خلاص. اوكي moving on, moving to this other slide. Okay, multiplying vectors. Now we have 3 ways of multiplication. You can either have a multiplication by a scalar. For example, if you can look over here down, this is z equal to minus 3i plus 5j. Now I multiplied a scalar with z, so 5, for example. You can also multiply the 5 inside. So 5 times minus 3 is minus 15. 5 times 5 is 25. So this is the first method of multiplying. You only multiply by a scalar. Nothing happens. تجيب الخمسة وتضربها فيهم واحد واحد. The method, it's called the scalar product or dot product. This one is interesting and you should pay attention to it. So the dot product is a dot b. It is defined as الماgnitude حق a ضرب magnitude b ضرب cosine الزاوية اللي بينهم. So phi here is saying is the angle between the two vectors. So you have 2 definitions for the dot product. You either use this definition, where you will get the magnitude and multiply them together, or you use this. So you know that A is basically x component, y component, z component, and B is the same thing. And if you want to get the dot product, you multiply the components one by one. يعني راح تقول له a dot b is equal to ax bx plus ay by plus az bz. All those things together. Hello, this is the second way of multiplication of vectors, which is called the dot product. And then again, you either use this this law. You only use it one if you have the magnitude of A and magnitude of B available. Sometimes you don't, sometimes you do. If you do, use them. If you don't, you have to use this. تجيب الكومبوننت حبة حبة وتضربهم في بعض. Okay. And also one more thing, you should pay attention that لما نضرب الكومبوننت مثلا AXI نضربه في BXI. So whenever you're multiplying I dot I, your answer will be 1. عشان كذا ليه يسموه scalar product؟ لأن الoutcome لما أجيب A dot B راح يطلع لي رقم ما راح يطلع لي شيء فيه I أو J أو K، ما راح يطلع لي كذا، هذاك يطلع في مكان ثاني. So always pay attention that your dot product will give you a value with no direction. يعني it will give you a scalar component. Okay, also you can apply the commutative rule. يعني إذا قلنا A dot B is the same as saying B dot A. I believe this is clear as well. Okay. Okay. Now the third. Oh yeah. Before the third multiplication rule, there is something called the. Let's read it together and then I will explain it. So a dot product is the product of the magnitude of one vector times the scalar component of the other vector. نقدر نقول ان ال A dot B يا اما انه يكون A cosine phi في ال B او A ضرب B cosine phi. هذه لها مسمتين اللي هي وش كان يسموها؟ A the component of A alongside B or the component of B alongside A. إذا الزاوية محطوطة مع ال A تقول له the component of A، وإذا الزاوية محطوطة حق مع ال B تقول له the component of B. هذا راح نشوفها في سؤال بس في النهاية which is basically the wording. يعني it's the same answer but you might get trouble if you mess this around. So this one is called the component of A along B and this one is called the component of B along A. يعني just remember that. Okay, let's move on. Here it says, let's read this one over here. It says, if the angle phi between two vectors is 0, the component of one vector along the other is maximum. ليه؟ لأنه cosine 0 is equal to 1. فإذا بجيب ال A dot B طبعا في الفيكتورز راح يطلع لي magnitude A ضرب magnitude B ضرب cosine 0 اللي هو الواحد راح يطلع لي بس AB. إذا this is the maximum value and we all know that the cosine cannot exceed 1 يعني دائما less than 1. no it could be بس يعني cosine 0 is 1 فخلاص راح يعطيك الماكسيموم. The component of one vector along the other is maximum and so also the dot product of the vectors. So if instead إذا theta حقتنا 90 we all know that cosine 90, what does cosine 90 equal to? No one. Okay. Cosine 90 is equal to 0. So if the angle between the two vectors is 90, then their dot product is 0. Okay, and so the checkpoint will basically talk about this. Vector C and D have a magnitude of 3 and 4 respectively. What is the angle between the direction of C and D? If the dot product is equal to 0, إذا dot product equals 0 إذا angle 90, we just talked about it. If it's 12 يعني كأنه ضرب 3 في 4 إذا الانجل حقتنا 0 because cosine 0 is 1. And what if it's minus 12 بس راح تكون الزاوية 180 لأن cosine 180 is equal to minus 1. Okay, I hope this is good, and if not, tell me. Okay. Now the third way to multiplying vectors is called the vector product, or it's called the cross product. The cross product can be done either by the right-hand rule or using the Kramer rule. So it is AB sine phi. So it's if A cross B will equal to AB sine phi. You can use the right-hand rule. I don't think you'll be using that in the paper. I will show you a rule. Yeah. So this is basically the rule. You can either memorize it or use the rule that I'm going to teach you right now. So let me just let me look at the next slide. Yeah, this is it. So this is the rule. Basically you will use the matrix. So you have A cross B. راح اسوي matrix تكتب فيها I J K هنا فوق، وراح تكتب الكومبوننت حق ال A في السطر الثاني وتكتب الكومبوننت حق ال B في السطر الثالث، وراح تسوي you will get it one by one. So the first one اللي تسويه انك راح تغطي السايد وتسوي على السايدات الاخرى. ف to get this side, to get this one, you will cross this place and then you work on those two وتسوي Kramer rule. So you will multiply this by this and then تطرح منهم this by that. راح يطلع لك AY BZ minus BY AZ وتحط جنبه I. And then the next one would be negative, and so you will remove this one. So you remove this one and you only focus on this thing and this thing. Okay, and so you will do the matrix here as well. So you'd say AX times BZ minus BX times AZ. And you will put J. And then the last one, you will do the same thing. Just neglect this one and then you will work with those. So AX times BY minus BX times AY. And this is basically your cross product. This is called the Kramer rule. It's long, I know, but sometimes if you're using two-dimensional vectors, then this will be 0 and 0, and so it will go easily. This checkpoint will talk about this, since the cross product is the magnitude and sign. So you should pay attention that sine 0 is equal to 0 and sine 90 is equal to 1. So here is saying vector C and D have a magnitude of 3 and 4 units respectively. What is the angle between the directions of the magnitude of the vector product C cross D is 0 and if it's 12. So based on the angles over here راح يطلع الكروس برودكت يساوي 0 إذا الزاوية 0 0 degrees، وراح يطلع الكروس برودكت at its maximum اللي هو 3 ضرب 4 لما يكون الزاوية 90. I hope this is also clear. Okay. Okay, the chapter is done right now. This is a summary. You should know that the component is when your angle is in the with the positive x direction, you should use cosine and use a sine for y and x. You should know this guy. You should know the angle. You should know the rules of adding and subtracting, and also the dot product. This is the main rule, and this is the secondary rule where you have to open them and take one by one. And this is the cross product. Just keep in your head that cosine 0 is equal to 1, cosine 90 is equal to 0, cosine 180 is equal to minus 1, and sine 0 is equal to 0, sine 90 is equal to 1, so that you can use them when you're talking about those two. Okay, now let's prepare for the problems and we should be done soon. Just give me a minute to prepare them. Can you see this right now? Do you all see this? Okay. Okay, so this is question 3. It's straightforward. It's saying a vector has a component of 15 meter in the x direction, a component of 50 meter in the y direction, and a component of 10 meter in the z direction. What is the magnitude of this vector? So let's call the vector, let's call it A. So it has 15i plus 15j plus 10z or 10k. And now he's asking about the magnitude. So you just say A is equal to, you put them like this. And you will get the magnitude. It should equal to 23.45. If anyone has anything, you can stop me and ask. Okay. The other question. Oh, it's broken. Okay, let me try to do one thing. Just give me a second. I will show it in a different way. Okay, so this is the question. It's a straightforward question, but we have to go through it. It's talking about two vectors. أعطاك A 5i minus 4j plus 2k, and then he gave you vector B, which is like that, and he gave you M as a scalar. Okay, you can see that M is in between in here, and he's talking about find A plus B, A minus B, and a third vector. Okay, so basically you're just playing around. So إذا بتجمع A plus B خلاص راح تجمعهم حبة حبة and you will keep M يعني it's a scalar. It's a scalar. So you can either consider it as 1 or anything like that. Just the idea over here is that whenever you want to do this subtraction, you would make it as A plus minus B, and so you will flip everything, and then you just have to find the third vector that makes this 0. So after you find this, just find the vector, just find it, and then replace every sign with negative, so that it will be flipped. يعني really, I don't think that this one needs any further explanation unless you ask me to do so. So is everything okay with this one? It's just addition and subtraction. Nothing more, nothing less. Yeah, I just talked about C. C يبيك تحصل third vector. ايش هو هذا الثيرد فيكتور؟ اذا جمعته مع ال A minus B راح يعطيك 0. اذا كل اللي راح تسويه بعد ما تحل هذه الفقرة راح تجيب الفيكتور حقها وتحط معاه إشارة سالب عشان راح مع بعض يصيروا 0. اوكي اوكي. السؤال اللي بعده it's broken. Okay, so Let's go again to the paint shop. Okay, you should be seeing this right now. Okay. This question is question 11. It says in unit vector notation, what is the sum a plus b if a is given as this and b is given as that, and what are the magnitude and the direction of a and b? Again, so you're just finding a plus b. You will basically add each one. So 4, and then you have minus 13. This is for I, and then you would have 3 plus 7. This is for j, and then you will have your like this, and then you will find the magnitude. So to find the magnitude, you put them in this guy. So minus 9 squared plus 10 squared. This will give you the magnitude. And if you want to get the direction, you should find tan theta. It should equal to, what was the law again? Did it have a minus sign? I don't remember. No, without. So yeah, only the components, 10 over minus 9. But then you should take invert. You should say that theta is equal to tan inverse of 10 over minus 9. Okay, so if you put this in your calculator, this would be 13.45, and this would be minus 48. So yeah, this is the direction. Okay, how many questions left? I believe 2. Yeah, 2. Okay. Okay, so this question, I believe you can see it now. Yeah. Okay, so this question is saying 2 vectors are represented as question 34. 2 vectors are represented as a is equal to this and b is equal to that. Find a cross b, a dot b, a plus b dot b, and the comp of a along b. Okay, so since we have the vectors, we can find their magnitude, and then we can make our life easier. So the magnitude of a, like, we can find it, which is 3 squared plus 5 squared, and then we can find the magnitude of b, which is 2 squared plus 4 squared, and then to get part a, which is we will angle as well. Theta is equal to tan inverse of I believe b over a. Oh no, this is not like this. We should make we should do the long one, since we don't have the angle. Okay, so let me rewrite this. This will only work if we have the angle, but since we don't, then we have to do the following. Okay, habba habba. So a cross b. So a cross b. We should be using this, the matrix I, J, K, and then we will put our numbers in 2, 4, 0, and we will find it. So this would be really quickly. This would be 5 times 0 minus 0 times 4, and this should be I minus 3 into 0 minus 0 into 2. This should be J, and then plus, now this is the real thing, 3 into 4 minus 5 into 2. This is K. And this should be equal to 12 minus 10, 2K. This is basically the cross product. We use the matrix rule. And if you want to find the dot product, so A dot B, you should do the other rule, which is component by component. So 3 times 2 plus 5 times 4. And since it's a scalar product, it will give you only a number. So 6 plus 20, which is 26. So this is the dot product. For part C, also, this is part A, this is part B. For part C, it's saying A plus B dot B. So just add A and B and then give them the dot product. So really quickly, A plus B, it will have 5I plus 9J. And then you will have the dot product with B. So your answer should be here 5 times 2 plus 4 times 9, and it should be 46. And now part D is saying the component of A along B. So as you can see, he's giving you the equation, the component of A along B, which is basically the dot product between them. So I believe you can get the angle as well. Yeah, but since we know that the component of A along B, the component of A along B is the dot product, so we already have the answer, which is 26. So just put it as 26. Okay. Okay, the last one. Okay. This question 41. Okay, so this question is saying use the definition of a scalar product. A dot B is AB cosine theta, and the fact that the A dot B is X BX, AY BY, AZ BZ to calculate the angle between the following two vectors. ف كل اللي بيك تسوي انك تحسب الدوت برودكت بالطريقه العاديه وبعدين تجيب الماجنتيود وتحسب الزاويه لواحد. So really quickly we can get the magnitude of A 4 square plus 4 square plus 4 square, and then we can get the magnitude of B, which is 3 square plus 2 square plus 4 square, and then نقدر نجيب الدوت برودكت بالطريقة التقليدية, which is 4 times 3 زائد 4 times 2 زائد 4 times 4. This will give us the dot product. بعدين كل اللي راح أسويه راح أستخدم ذا القانون A dot B is equal to AB cosine theta. راح أقول cosine theta is equal to A dot على AB, and then at the end I will use the cosine inverse. So quickly I will give you the answers. This is 6.93. This is 5.39. This is 36. So 36 over here. And this is basically, this is A times B. Okay, now we can just find the angle and we're good to go. Okay, so the angle is 15.46 degrees. Okay, this is it. Sorry if I took way too long. I hope everyone got to understand at least something. And if you have any doubts, you can message me, or yeah, you can message me on WhatsApp at any time, and hopefully I can help you out. Okay, that's it for today. No, it's okay. It's okay. Since the session is recorded and everything, you can go back to it at any time you can. You can scroll through it. You can download it, because after 1 month, the session will go. Keep it with you if you need anything. I will upload the solution on Blackboard, and I will upload the notes themselves on Blackboard. And yeah, wish you the best, all of you. Thank you for staying for this long. Okay, I'll stop the recording now. And if you have anything else, you can